Hello everyone. A very good afternoon all of you dear ones, and I know there is a bit delay in this session and I'm really sorry for this particular thing, and obviously today you all are waiting for this particular session as because the reason is today we are going to discuss the super 35 organic questions, the important organic questions over here. Hello Anup, hi Riddhi, hello Aditya, hi Rohit, yes. Hello Pankaj, good afternoon. Okay, hi Sahil. Fine. Hello Mr. Captain, good afternoon. Hi Aman, good afternoon. Hello Jayesh. Hi Karthik. So today I am actually seeing that so many of you are there just because today's organic chemistry session, the 3 hours marathon, you all are excited and waiting for this session. Yes ma'am, of course. Hi Ashwant, hello Vishwakarma, hi Sridhar, good afternoon. Welcome to the session. Hello Arnab. Hi Rahul. Okay dear ones. Hello Vivek. Good afternoon dear ones. So today we are actually going to talk about organic chemistry. So first of all, let me tell you that you need to fasten up your seatbelts, and yes, you need to come along with me on this particular 3 hours journey to learn, to discuss the super 35 important organic chemistry questions for your coming JEE examinations. Isn't it? Yes ma'am. Hope that you had your lunch, of course, and I just want that within these 3 hours you are not going anywhere. You will be with me and you'll solve the questionnaires here itself. Hi Satyendra, hello Mohammed Arif, hello Umesh. Okay dear ones, so let's start our session because it's already 10 minutes delay for this particular session. So let's move ahead. And first of all, let me tell you one thing, that is that you need to actually hit the like button, subscribe the channel for the further notifications of the classes. The classes kind of such today we are going to take about. Fine. Well, dear ones, you need to share this particular session at this right moment among your peer groups, among your friends. So do not delay in this particular thing. Fine. Yeah, hi Prabha, good afternoon. Welcome to the session. So dear ones, one more thing, one more announcement before I just move ahead with question number 1 of this particular session. Let me tell you just one thing, that we actually know that you enjoy watching Aakash, Byju's chemistry videos just to boost up enhance up your JEE preparation. Okay. So I just want to say one thing. Do you want any personalized help? You'll say, yes ma'am, we want the personalized help. Okay, so that's the main thing. Well, there is a good news for all of you guys that the Aakash Byju's now brings to you highly personalized app. Okay, that is going to monitor your journey, learning journey and overall performance. Okay, so beside that particular app, and we guys are going to tell you about your weaknesses, we will be actually talking about your strengths. Okay, and how you can outsmart the competitors thereby. So you need to actually do what? There is a link given in the description box. Click on that particular link, explore this particular app. You are going to actually get all the things in free for about 14 days. So just explore this particular app. Okay, so all your topics are going to cover while you are actually going to talk about this particular app. Moreover, there will be animations with the help of which the complicated concepts are gonna be simplified. I know you are actually having fear of organic chemistry, so not to worry, just explore this particular app. You will find it that it's actually making your chemistry, the organic chemistry, very, very simple. Not only organic chemistry, all the subjects of your examinations, physics, chemistry, mathematics. It's over here, me the chemistry teacher, your Arkimam, so only I'm actually talking about the same. So, to learn more, you need to click the link in the video description, in the descriptions given below. And it's actually free of cost for 14 days. So, dear ones, what we should do? Together, let's make it happen and let's crack our JEE examinations. Okay, so Mohammed Arif, आज हम super 35 questions कर लेते हैं, and then we'll be actually talking about all other sessions. So focus on today's session only. Here we are with the very first question of the session. So dear ones, just let me know the answers. Just let me know the answers. Okay. And yeah, bombard the comment box, bombard the comment section with your answers. Okay, fine, bombard the comment box with your answers, and I just want Everyone should participate. Fine. So the very first question is the IUPAC name of the given compound is. The IUPAC name of the given compound is. So this is a given compound to us. What will be its IUPAC name? 3,3-dimethyl 1-cyclohexanol. Vivek says option number A. Karthik says option number A. Aryan says option number A. Will it be option number B or C or D? So tell me. Riddhi said it's option number A, ma'am. Okay, guys. So yes, option number A is absolutely right. Arpita, dhyan se dekho. Just have a focus on the question. So all of you are saying option number A. Mohammed Arif, it's the wrong answer. It's option number A, the right answer. How come you are going to talk about its IUPAC nomenclature? So obviously it's alcohol. Okay, I mean to say this particular carbon atom do have the OH group present. So we are going to, if I want to give the numbering, I'll be starting from here. It's 1, 2, 3, 4, 5 and 6. OH is a functional group, so obviously we are going to name that particular carbon atom. We are going to give the particular carbon atom containing OH group as the first position. Fine. So over here it is gonna be 3, 3 because at the third positions we are actually having 2 methyl substituent. So 3, 3 dimethyl, 3, 3 dimethyl 1, because at the first position we are having the all group, so it will be cyclohexanol. It will be cyclohexanol. Okay, the thing is clear to you? Yes, ma'am. So it's option number A, the right answer, dear ones. Okay, fine. Chaliye, let's move ahead and let's talk about the second question in front of you. The IUPAC name of the given compound is. Tell me the IUPAC name of this particular given compound to us. All wrong answers deleted. Yes, of course. B, C, D were not the right answers. It was the option number A, the right answer. Well, let me know the right answer for this particular question. Sahil says it's neophenyl. Sahil, is it? Will this particular compound be named as neophenyl? Is there any compound? We talk about neophenyl. We actually talk about neopentyl basically. We talk about neopentyl, okay? Yes. So Lakshmi has said it's option number C, ma'am. Okay, 1, 1, 1, 1, 1 tetracyclohexyl methane you are actually talking about. Okay, so I'm getting all sorts of the answers. Rohit says A or B. Rohit, you're confused. Yashwant says option number B. Mohammed Arif says option number C. Wrongly typed. Yes, it would be neopentyl. I totally agree. It will be neopentyl. Basically, it should be written over here. Well, this particular compound name is option number C. It is 1, 1, 1, 1 tetracyclohexyl methane, and Lakshmi was the very first one who said the right answer. So, Mr. Gamer, your answer is not actually right. Riddhi says the right answer. Yes. So, you can see it's the carbon atom, and on this particular carbon atom, there are 4 cyclohexyl groups attached. Why not C? Why not C means what, Captain? It's answer number C, the right answer for the question asked for. See, it's the cyclohexyl groups. These are the cyclohexyl groups that are attached on the same position. So we are going to say, and how many cyclohexyl groups are there? 4. So we are going to write it as 1, 1, 1, 1 tetracyclohexyl methane. Why methane? Because only one carbon atom is there. Yes, Karthik says absolutely right. They are not phenyl groups, rather they are cyclohexyl group. So Arnab, there is nothing to understand in this particular question. It's only one thing, that to one carbon atom 4 cyclohexyl groups are attached. So we'll say 1, 1, 1 tetracyclohexyl, okay, and since we're having one carbon atom, yes, so it will be methane. It will be then methane, tetracyclohexyl methane. Absolutely right, Yashwant. Yes, so it's option number C, the right answer. Well, if I just talk about something else, if I just talk about neopentyl, if you say, so over here talking about neopentyl, see, neopentyl group, if I just want to talk about, so it's one carbon, 1, 2, 3, and what it will be, it will be CH2, and further there will be something, so it's CH3 over here. This is our neopentyl group basically. Fine? Yes, no issues. So option number C is the right answer. Moving ahead, and let's talk about the next question, and the question is the compound that contains what? All the 4, 1 degree, 2 degree, 3 degree and 4 degree carbon atoms. We need to talk about a compound that contains all the 4 degrees carbon. I mean to say 1 degree. I mean to say primary carbon atom, secondary carbon atom, tertiary carbon atom, and quaternary carbon atom. So can you tell me which is that particular compound having all the 4 types of carbon atom? Astha says it's option number B. Astha is saying it's option number B. Well, all of you are saying option number B. Vishwakarma, Prabha, Priyanshu, okay, Kirtan, Aakash, okay, fine. All of you, Karthik, fine, good ones. So it's option number B, the right answer. Wow, that's absolutely right. Krishna says it's option number B. Mr. Gamer also says it's option number B. Chaliye, I believe that all of you are actually telling me the right answer. 2,3,3 trimethyl pentane. Yes, absolutely right. It's option number B, the right answer. See, if you check any other compound, first of all, you need to write the structures, okay? First of all, you need to write the structures. Where if I just talk about option number B, since all of you are telling me, so let me write the structure of it. So it's pentane 1, 2, 3, 4, and 5. At the second position, we are having a methyl group. And at the third position, we are having the 2 methyl groups, kind of like this. Okay. It's H over here, and it's H2 over here and CH3 over here. So it's 1 degree carbon atom. Okay. This one is the 2 degree carbon atom. Okay. This one is 3 degree carbon atom. And this one, if I just talk about it, is 4 degree carbon atom. 1 carbon atom is attached to 4 carbon atoms. 1 carbon atom is attached to 3 carbon atoms. Okay. So I hope you know the difference between 1 degree, 2 degree, 3 degree and 4 degree carbon atoms. I hope you, all of you, know this particular difference, since you are actually going to give your JEE mains the next month itself. Okay, okay, fine. So it's option number B, the right answer. See, Mr. Vicky, what I actually want to talk about, JEE can ask anything, simplest to simplest, okay, and difficult to difficult, toughest to toughest. Fine, so anything can be asked. That's the main thing. Okay. So if I just talk about any other, suppose if I talk about 2,3,4 trimethyl pentane. Okay. So it's carbon 1, 2, 3, 4 and 5. So at second position we do have a methyl group. At the third position also methyl group, and at the fourth position also at the methyl group. Okay. So in this particular compound, what we are going to have, can you have a look? We are actually having 1 degree carbon atoms. These two are 1 degree carbon atoms, okay? And this one, and this one, these are 3 degree carbon atoms. So 1 degree and 3 degree carbon atoms. So option number C will not be there. Similarly, if I just talk about 3,3 dimethyl pentane, over here we'll be actually having what? Okay, wait a minute. If I just talk about 3,3 dimethyl pentane, so it's 1, 2, 3, 4 and 5. So it is this CH3 over here and CH3 over here. Fine. So over here we are not going to have tertiary carbon atom. We are not going to have tertiary carbon atom. Okay. So over here we are going to have 1 degree only, 2 degree and 4 degree carbon atoms. Rather we want all the carbon atoms. 1 degree, 2 degree, 3 degree and 4 degree. So now not actually spending more time on this question. Option number B is the right answer. Moving ahead, and let's talk about the next question over here. Okay, fine. So in the anion, this particular anion HCOO negative, the 2 carbon oxygen bonds, the 2 carbon oxygen, okay, gamer says कि मैम 4 degree समझ नहीं आया. 4 degree carbon atom का मतलब ये है कि ये carbon atom है and it is attached with 4 carbon atoms. So this carbon atom is actually known to be as quaternary, or you can say 4 degree carbon atom. Okay, well, if I just want to talk about this particular question, okay, this question, the fourth question, in the anion HCOO negative, the 2 carbon oxygen bonds, they are found to be equal lengths. What is the reason behind it? And I'm getting the answer. That's option number B, all of you are saying. It's option number B. The anion HCOO negative has 2 equivalent resonating structures is the right answer. Obviously B, Asta says yes, of course. So it's option number B, the right answer. Saying that C double bond, CO double bond, okay, the CO double bond is weaker than CO single bond is actually not the right reason for this particular question. Saying that the anion is obtained by the removal of a proton from the acid molecule, it is actually not the right reason. Talking about the electronic orbitals of carbon atoms are hybridized, this is also not the right reason basically. Okay, so over here what I want to say, if I just talk about HCOO negative, so you can just have a look. It's HC double bond O and O negative. If I just talk about its resonating structures, we are going to have the two equivalent resonating structures. Okay, so through resonance both resonating structures are equivalent. That is why the two CO bond lengths are found to be, that is why the two CO bond lengths, if I just talk about, they are found to be equal in nature. So all of you as said, it's option number B, the right reason for this particular question. इस question के लिए जो right reason है वो option number B है. अगर हम ये कहें कि CO single bond is stronger than CO double bond, ये reason right नहीं है इस question के लिए. Saying that कि anion हमें तब मिल रहा है after the removal of a proton, ये भी सही reason नहीं है. ठीक है, so it's only option number B, the right reason for the question asked for. चलिए, let's move ahead and talk about the question number 5th over here. Carboxylic acids do have a higher boiling point than aldehydes, ketones and even alcohols of comparable molecular mass, and it is due to what? It is due to what? Just let me know. Asta said it's option number C, formation of intermolecular hydrogen bonding. Asta is saying it's option number C, formation of intermolecular hydrogen bonding, and it's all of you guys saying the right answer, but Riddhi, you said it's option number D. Riddhi, option number D says more extensive association of carboxylic acid via van der Waals forces of attraction. हमें एक्चुअल में बताना है कि हायर बॉइलिंग पॉइंट क्यों है कार्बोक्सिलिक एसिड का, अगर हम कंपेयर करते हैं विद एल्डिहाइड, कीटोन्स एंड इवन अल्कोहल्स हैविंग द कंपेरेबल मॉलिक्यूलर मास. Comparable molecular mass, as said by most of you. Krishna, no, that's not the right answer. It will be the formation of intermolecular hydrogen bonding. Okay, so if I just talk about the carboxylic acids, it's R C double bond O, and it is O and H over here. So you can just see over here, there will be what? There will be, I'll say what I am going to say. It's the strong intermolecular hydrogen bonding that is going to actually happening over here. So carboxylic acids do have higher boiling point than aldehydes, ketones. Okay, and also alcohols of the comparable molecular mass, just because of the formation of intermolecular hydrogen bonding, जो कि बहुत ज़्यादा strong होती है. ठीक है रिद्धि, आप जो कह रहे हैं it undergoes association, मैं इसको deny नहीं करती हूँ. ठीक है, मैं इसको डिनाई नहीं कह रही हूँ, लेकिन एक्चुअल में राइट रीजन क्या है? व्हाट इज द मोस्ट सुटेबल रीजन? द मोस्ट सुटेबल रीजन इज द फॉर्मेशन ऑफ इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग, एंड दैट इज स्ट्रॉन्गर इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग. ठीक है, तो यहाँ पर इनका हायर बॉइलिंग पॉइंट क्यों होता है? क्यों होता है हायर बॉइलिंग पॉइंट? बिकॉज ऑफ द फॉर्मेशन ऑफ इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग. द मोस्ट अप्रोप्रिएट आंसर टू दिस पर्टिकुलर क्वेश्चन. दैट इज व्हाट आई वांट टू मेक द थिंग्स क्लियर. तो चलिए, लेट्स टॉक अबाउट द नेक्स्ट क्वेश्चन. इस क्वेश्चन को बहुत ध्यान से पढ़िएगा, आंसर मुझे सही मिलना चाहिए. अरेंजमेंट ऑफ CH3 whole thrice carbon, okay, CH3 whole twice CH and CH3 CH2 when attached to benzyl or an unsaturated group in increasing order of inductive effect is. In increasing order of inductive effect is. Increasing order of inductive effect की मैं यहाँ बात कर रही हूँ. आकाश ने बोला it's option number B मैम. Okay, Karthik says option number B. Rohit says option number B. Krishna says option number B. Aakash says option number B. Shutus says option number B. Riddhi, Sahil, Arpita, Prabha. Okay, so all of you are actually saying that ma'am it's option number B, and it's absolutely right. देखिए यहाँ पर कभी कभार बच्चे कंफ्यूज हो जाते हैं, हाइपर कॉन्जुगेशन इफेक्ट को भी वो यहाँ अप्लाई कर देते हैं, लेकिन क्वेश्चन में पूछा गया है इंडक्टिव इफेक्ट. यस, देयर आर सम क्वेश्चंस जहां पर आपसे इंडक्टिव इफेक्ट नहीं पूछा जाएगा. आपसे एक तरह से क्या पूछा जाएगा? आपसे पूछा जाएगा रेट ऑफ इलेक्ट्रोफिलिक रिएक्शन के बारे में, रेट ऑफ एक्टिवेशन के बारे में आपसे पूछा जाएगा. लेकिन यहाँ पर सिंस वी आर टॉकिंग अबाउट इंडक्टिव इफेक्ट, तो यहाँ देखिए इंडक्टिव इफेक्ट के बारे में मैं क्या कहना चाहूंगी आपको कि सिंस ऑब्वियसली वी डू हैव, दिस इज द कार्बन एटम हैविंग 3 मिथाइल ग्रुप्स. This is the carbon atom having 3 methyl groups, and if it is actually attached to an unsaturated group over here, fine, or the benzyl ring, whatever the thing has been said over here, if we are talking about the increasing order of inductive effect, so inductive effect is more in this particular group. Okay, tertiary butyl group. Reason being because we do have 3 methyl groups over here, so all are electron donating groups. So over here there will be more of inductive effect, more of plus I effect. Yes, CH3 is electron donating group, so it is going to activate it. So we need to talk about in order of inductive effect. तो यहाँ पर hyper conjugation वाला phenomena नहीं आपको put करना है. So it will be CH3 whole thrice carbon, then CH3 whole twice CH, and CH3 CH2 then. 3 degree, 2 degree and 1 degree. So option number B is the right answer for the question asked for. Hope that you are getting the things clear. Hope that's the things has been clear. Yes, विवेकानंद जी, तभी मैं आपको कह रही हूँ कि यहाँ पर हम अल्फा वाला चीज नहीं अप्लाई करने वाले हैं. ठीक है, हम यहाँ अल्फा वाली चीज अप्लाई नहीं करेंगे. इवन अगर आप अल्फा 9 अल्फा हाइड्रोजन्स की बात कर रहे हैं, टेकिंग द केस ऑफ हाइपर कॉन्जुगेशन, तो आप यहाँ पर देखिए अल्फा कार्बन एटम्स जो है हमारे पास में, अल्फा कार्बन एटम के अल्फा हाइड्रोजन्स को हमें देखना है बेसिकली. ठीक है, यस. तो अगर कार्बन पे अगर ये इस तरह का हमारे पास आ जाता CH3 होल थ्राइस C पॉजिटिव, ठीक है, सो इसका अल्फा कार्बन 3 अल्फा कार्बन एटम्स हैविंग 9 अल्फा हाइड्रोजन एटम्स, दैट्स एब्सोल्युटली राइट. लेकिन ये अटैच्ड है किसके साथ में? अनसैचुरेटेड ग्रुप या बेंजाइल रिंग के साथ में अटैच्ड है. ठीक है, सो प्लस आई इफेक्ट को देखते हुए हमें इसका आंसर देना है. एब्सोल्युटली राइट. सो ऑप्शन नंबर बी इस क्वेश्चन के लिए एप्रोप्रिएट आंसर है. ओके अर्णव, ओके. चलिए लेट्स मूव अहेड एंड लेट्स टॉक अबाउट द नेक्स्ट क्वेश्चन हेयर एंड व्हाट वी आर गोइंग टू टॉक अबाउट. देखिए, हाउ मेनी स्ट्रक्चरल आइसोमर्स आर पॉसिबल व्हेन वन ऑफ द हाइड्रोजन एटम्स, कितने स्ट्रक्चरल आइसोमर्स पॉसिबल हैं व्हेन वन ऑफ द हाइड्रोजन एटम्स इज रिप्लेस्ड बाय अ क्लोरीन एटम इन द मॉलिक्यूलर फॉर्मूला ऑफ डाइफिनाइल मीथेन. क्या बात है आकाश, एज इफ यू हैव एक्चुअली what should I say, revised your whole organic chemistry and you are giving the all right answers. Very good, Aakash. Vivek says option number B. Astha says option number 4. Astha, it's option number 4. No. Okay, I got your point. You are saying there are 4 structural isomers possible. So yes, it's option number B, the right answer. हाँ जी, कैसे? अगर मैं यहाँ पर हाइड्रोजन को रिप्लेस कर देती हूँ with the chlorine atom, तो see, we are going to have 4 structural isomers. So it's CH, Cl over here, this one. The other one, if I just talk about it, CH2. Okay, and wait a minute, I did a mistake, wait a minute. So it's CH2 over here, fine, and 1 chlorine this side, fine. Okay, this position, this position, this position and this position, they all are same. So any one of these position, if occupied by chlorine, it is actually the same, fine. Talking about the third one, if I just talk about, okay, it's CH2 over here, this, and 1 chlorine over here. And if I just talk about the fourth one, it's CH2 over here, this, and chlorine over here. So we do have in total 4 structural isomers. 4 structural isomers. So it's option number B, the right answer. Option number B हमारा सही जवाब है. बहुत सारे लोगों ने, इवन मोस्टली लोगों ने, आप लोगों ने सही जवाब दिया है ऑप्शन नंबर बी, या फिर कहिए 4. दैट्स एब्सोल्युटली फाइन, अप्रोप्रिएटली फाइन. ठीक है, क्लियर है? ओके, कुणाल, वेट, होल्ड ऑन. These are the questions I have taken, super 35 important questions for your JEE mains. Okay, so be there. We'll be talking about the advanced level questions, sometimes others. So आप इनको solve कीजिए. That is the main practice we are actually going to do over here. चलिए, let's talk about the next question. If the optical rotation produced by the compound A is plus 52 degree, if the optical rotation produced by the compound A is plus 52 degree, the one produced by compound B will be what? So just let me know the answer of this question now. Aakash, Astha, Prabha, Krishna, Kunal, Riddhi. Suresh said that, ma'am, it's option number A, absolutely right. अर्पिता, ऑप्शन नंबर सी इज नॉट द राइट आंसर. अगर कंपाउंड ए का ऑप्टिकल रोटेशन प्लस 52 डिग्री है तो कंपाउंड बी का क्या होगा? सिंस इफ यू जस्ट सी दे आर द मिरर इमेजेस ऑफ ईच अदर. ओके, since A and B, they are what? They are mirror images of each other. They are enantiomers basically. They are enantiomers. So specific rotation of B will be minus 52 degree because enantiomers do have equal and opposite specific rotation. So it's option number A, the right answer. Yes, Ayushi, Roshan, Vivek, Pravan, प्रभा, एब्सोल्युटली राइट पवन, ऑप्शन नंबर सी नहीं होगा. ओके, यस, यहाँ ऑप्शन नंबर सी को हम नहीं लेने वाले. दे आर नॉन सुपर इम्पोजिबल मिरर इमेजेस ऑफ ईच अदर. दे आर enantiomers and enantiomers do have equal and opposite specific rotation. So if the compound A is having plus 52 degrees, so the other compound B is going to have minus 52 degrees. And in total, if I just talk about their optical rotation, so plus 52 degree minus 52 degree comes out to be 0 degree. Okay, so they are going to cancel out each other's what specific rotation. But हम वो नहीं पूछ रहे हैं. What we are actually talking about, we are talking about the optical rotation that is produced by compound B. क्लियर है ये वाली चीज? क्लियर है? ओके, चलिए, तो इट्स ऑप्शन नंबर ए द राइट आंसर. लेट मी जस्ट टॉक अबाउट the halogenation of alkanes. Fine, it's question number 9. So the halogenation of alkanes involves the formation of which of the following intermediates? बताएं आप मुझे. हाँ जी, just let me know. Okay, so Arpita says B, Krishna says B, Archit says B, Radhesham says D. So B, D, B, D. मैम इट्स B. B कैसे होगा ये बताओ चलो मुझे. अर्णव बताएंगे. B कार्बोनेशन, कार्बोकेटायन, थॉर ऑफ गॉड. D कह रहे हैं, B कह रहे हैं, ऑप्शन D B चल रहा है यार. तो यस विश्वकर्मा, D is the right answer. Absolutely right. D is the right answer for this particular question. डी होगा, फ्री रेडिकल्स होगा. हेलोजिनेशन ऑफ एल्केन्स की बात कर रहे हैं. सबसे पहले अगर मैं हेलोजिनेशन ऑफ एल्केन की बात करती हूँ, सपोज कीजिए मैं क्लोरिनेशन कर रही हूँ यहाँ पर. सो ऑब्वियसली जो मेरा क्लोरीन मॉलिक्यूल है यहाँ पर इनिशियली सबसे पहले उसका होमोलिटिक क्लीवेज होगा. When the homolytic cleavage takes place in the presence of UV light, we are going to get the chloride radical. We are going to get this particular chloride radical. This is the initiation step. Yes, absolutely right. Yes, absolutely right, Mr. Jack Sparrow. Yes. So उसके बाद क्या होगा? Now the second step will be the propagation step, wherein this chloride radical, if I just talk about this chloride radical, it is going to react with this. Suppose if I do have methane, so again over here what I'm going to get is the methyl free radical. Methyl free radical. So can you just see over here this methyl radical we have got? Yeah, chloride radicals. Yes, of course. So यहाँ पर free radicals होंगे. The formation of which involves the intermediates. Which intermediate? Free radical intermediates like methyl free radical, ethyl free radicals, kind of like this. And the last step will be the chain termination step, wherein the two chloride radicals can react to give us the chlorine molecules. Two methyl radicals can react with each other to give us the corresponding ethane. Okay, or you can say chloride and methyl radicals, they can react with each other to give us to methyl chloride. That's what I want to actually talk about. ओके, समझ में आया? सो यहाँ पर कार्बन आयन, कार्बोकेटायन, कार्बीन्स कैसे आप बोल सकते हैं? It's really very famous reaction, halogenation of alkanes. We actually talk about many a times now. So how can you actually point this particular question to be the wrong answer for you? Okay, see, JEE Mains is gonna be very easy for you until and unless you open your eyes and be attentive in your examination. Okay, otherwise you will say silly mistake से हमने ये question गलत कर दिया. Silly mistake is not the excuse for J or JEE Mains. Okay, it's the excuse till you enter. Okay, or you can say it's an excuse before you enter your examination. Okay, so उससे पहले exam देने से पहले कितने भी silly mistakes कर लो, fine. But in your examination hall, giving the exam, you cannot actually afford the silly mistake. Fine. Yes, no issues, no issues. Be attentive, dear ones. Chaliye, let me talk about this particular question. Oh wow, it's a very good question. See, I really like these particular type of the questions. Yes, absolutely right. Mistakes are never silly. They are blunders you are going to make in your examination. So, yes, Mr. Vicky, these type of the questions do come. Okay, there may be some difficult questions approaching towards you, but yeah, such type of the questions do come. Now tell me this particular question. The major product of the following chemical reaction is, it's CH3, CH2, CN. Fine. Which first of all reacts with H3O positive, heat it up, then with its SOCl2, okay, and then it's basically the Rosenmund reduction that is going to take place. So at the end it will be propanol you all are going to talk about. Yes, of course it will be propanol. So initially if I just talk about, it's the cyanide, CH3 CH2 and cyanide. Okay, it undergoes acidic hydrolysis, that is what we have done initially, and heat it up. So we are going to get what? We are going to get the acid CH3 CH2 C double bond O OH. This is the acid we will be actually going to get. Then sulfuryl chloride SoCl2. When acid reacts with SoCl2, we are going to get CH3 CH2 C double bond O Cl. Okay, now this is our acid chloride basically. So over here it's PD BaSO4 and hydrogen. So it is Rosenmund reduction that is actually going to take place, and hence there will be the reduction of this acid chloride to corresponding aldehyde, which is CH3 CH2 and it is CH double bond O. Okay, fine. Yes, so it is option number C, CH3 CH2 CHO. Yes, of course, Mr. Radesham, absolutely right. So most of you have given the right answer for the question. Very good, dear ones. Keep up the good work. Rest others, we are not going to get over here. So moving ahead, and it's question number 11 in front of you. This is question number 11 in front of you. Okay? So chaliye, let me know about the answer of this particular question now. Come on, dear ones. Hydrocarbon A. It's a really very good question. Ye question A kya do baar, I remember, yeah, 2 to 3 times it has actually came in your JEE Minx within an interval of some period of a time. Fine. So hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, which by Wood's reaction is converted to gaseous hydrocarbon containing less than 4 carbon atoms. So what is A? So there is a hydrocarbon A, fine ma'am, that reacts with bromine by substitution to form an alkyl bromide. Now this alkyl bromide, which when undergoes Wood's reaction, that means when it reacts with sodium in presence of a dry ether, we are going to get a gaseous hydrocarbon which is less than 4 carbon atoms. Okay, 4 carbon atoms. So you all have said that, ma'am, it's option number CH4. Yes, Karthik, absolutely right. Yes, it's option number 4th. That means methane. Hydrocarbon A is methane. See, if you take this hydrocarbon, then you are going to get hydrocarbon at the end product. If you are going to mark option number A as the right answer, then the product hydrocarbon, the gaseous hydrocarbon, will be having carbon atoms more than 4. We want carbon atom less than what? What less than? Less than 4. So it is this hydrocarbon we are going to talk about. Fine. So it's CH4. Okay, which when reacted with bromine in the presence of light, we are going to get CH3Br. This is what we are actually talking about. Fine. Okay, fine. Okay. Yes, so over here it's a sodium. Now when we treat this methyl bromide with sodium in presence of dry ether, what we are going to get? It's the Wood's reaction we are talking about, Wood's reaction, and it's CH3. It will be 2 times of CH4, 2 times of this, so twice, and at the end we'll be getting CH3, okay, plus NaBr. Fine. Mr. Ganesh, you says that how we are going to get, it's the Wood's reaction. These are Wood's reaction. This is Wood's reaction, in which what we are going to get in Wood's reaction, when same alkyl halide is used, the product alkane we are going to obtain with even number of carbon atoms. Fine, that's the main thing we are talking about. So it will be option number D the right answer. Option number D the right answer. Yes. चलिए let's move ahead and talk about this particular question. इस question के बारे में चर्चा करते हैं, wherein it's the, we want the reagent A which actually converts the reactant into product. Now can you see in the reactant we were having CH3, okay, and OCH3. OCH3 is as it is, but CH3 has changed to COOH. So obviously the answer you know for this particular question, the very suitable best answer for this particular question is option number B, alkaline KMNO4. Alkaline KMNO4. Is the thing clear? See, if I just talk about HCl in the presence of zinc amalgam, it's the Clemmensen reagent we are talking about. So if I just talk about Clemmensen reaction, so we are going to get this as it is. So this is not what is going to happen over here. Alkaline KMNO4 is the best answer for this question. Okay, and lithium aluminum hydride and NaBH4, if I just talk about, these are the reducing agent. Rather we want the oxidizing agent, the strong oxidizing agent. Yes, so it's option number B the right answer. Option number B the right answer. Okay, let's move ahead and let's talk about the next question. And herein what we are actually having, just have a look what we are actually going to have. So चलिए, yes, absolutely right, Karthik, आप बिल्कुल सही कह रहे हैं. It's question number 13. Now we are going to talk about on heating sodium acetate. Okay, with soda lime, the hydrocarbon obtained is, the hydrocarbon that is obtained is what? So Ayush, Harsh, Nagesh, okay, Vishwakarma, one carbon atom less, we are going to get methane is the right answer. Methane is the right answer. So it's option number D the right answer. The ones who are saying option number C and B, that is actually not the right answer. Your answers are actually not right. Okay, your answers are actually not right, dear ones. नहीं है आंसर आपका right. Yes, it's option number D the right answer. Yes, decarboxylation reaction है यहाँ पर. So यहाँ देखिए what we are going to do is CH3, C double bond O, O negative, Na positive. Fine, this is sodium acetate we are having. Reacting this with NaOH and CaO. Fine. Herein it's the decarboxylation reaction we are talking about. Decarboxylation reaction we are talking about. So at the end we are going to get CH4 plus Na2CO3 basically. ठीक है. So can you just tell me what's the use of this CaO in this soda lime? Okay, can you just tell me? So it's option number D, and it's like this only I'm actually talking about. What's the use of CaO over here? Why we are using CaO, calcium oxide? Just let me know. Aakash, Vicky, Radhesham, Astha, Pradeep, tell me why we are actually using what? CaO. Yeah, my name is Rakhi. Fine, to remove acidic impurities. Well, let me tell you one thing, that this NaOH is hygroscopic in nature. So what happens that CaO, calcium oxide, it absorbs the moisture of NaOH during the reaction and it keeps it dry. Fine, so that efficiency of NaOH is going to increase and it can further proceed the reaction in a maximum efficiency. So basically calcium oxide permits the reaction to be carried out at a relatively higher temperature also to ensure the complete decarboxylation. Fine, this was randomly just asked about the calcium oxide usage. Fine, so let's move ahead and let's talk about the next question in front of you guys. चलिए इसका आंसर बताइए. अब इसका आंसर क्या होगा ये बताइए, फटाफट से बता दीजिए. चलिए, हाँ जी अर्पिता, आपने बिल्कुल सही बोला. यस, ड्राई रखना ज़रूरी होता है. यस, हमें मीडियम जो है अपना ड्राई रखना है, तभी वो इजीली रिएक्ट कर पाएगा. यस, ऑफ कोर्स, एब्सोल्युटली राइट. सो विच ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट? विच ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट अबाउट साइक्लोहेक्सेन? साइक्लोहेक्सेन के लिए कौन सी पर्टिकुलर स्टेटमेंट करेक्ट नहीं है? इट इज अ मेंबर ऑफ द होमोलोगस सीरीज विद जर्नल फॉर्मूला CnH2n, where N is 3, 4, 5, 6, etc. Fine. And B says it is a saturated cyclic hydrocarbon. अच्छा भाई, it is very unstable strained compound. It can exist in different conformations, out of which the most stable is the chair form. So the not correct answer is which one? Vicky says option number C. Arpita says option number C. Riddhi says it's option number C. Jyoti says option number C. Who is saying that it's option number B? Asta, how can it be option number B? It's a saturated cyclohydrocarbon. Yes, this is the saturated cyclohydrocarbon. Okay, so very first, if I just talk about the very first statement, yes, it is the member of homologous series with the journal formula CnH2n. So if I just place cyclohexane, it's C6H2 into 6, so it is C6H12. This is cyclohexane. Okay, fine. This is right. That means this one is true. Correct. It is a saturated cyclic hydrocarbon. Yes, it is a saturated cyclic hydrocarbon. saturated cyclic hydrocarbon? Yes, yes. So it's true. It is very unstable strained compound. This is incorrect. That means this one is false. It can exist in different conformations, out of which the most stable is the chair form. Yes, it is also true. Okay, so if I just talk about the stability of different conformations of cyclohexane, so it is basically chair form followed by boat form, then it is twist boat form, twist boat form, twist boat form, and then it's a half chair. Then it's a half chair. It's the chair form which is really very stable. This chair form is really very stable. Can you just see? Angle strain is very least over here if I just talk about. Moreover, the repulsions is also less. Repulsions between the hydrogen atoms, if I just talk about, it is also less over here. So chair form is the most stable form. Talking about boat form, over here there will be interaction between these flagpole hydrogens. Fine, yes. So stability decreases. Talking about twist boat, if I just talk about, so just have a look. If I just talk about twist boat, fine, so this is our twist boat having strain in it. Fine, yes. And the half chair, if I just talk about, which looks like this is the half chair we are talking about. Fine. So if I just talk about one thing, what one thing, ma'am, you are actually talking about? Option number C, saying that it is very unstable strain compound, is actually not correct. It is actually not correct basically. Fine. So A, B and D are true, and the one which is not correct is option number C. It is very unstable strained compound. ये नहीं correct है, तो यही हमारा आंसर सही होगा इस क्वेश्चन के लिए. No issues. Yeah, chair form is the transform, absolutely right. यहाँ पर जो repulsion हो रहा है, see यहाँ पर आप देखेंगे, these are actually far from each other. If I just talk about here also, we can just see far from each other. So repulsions यहाँ पर बहुत कम होंगे. That's the main thing. Fine. So chaliye here we are talking about the next question, the question number 15th in front of you. Among the species given to you, the resonance stabilized carbocations are. The resonance stabilized carbocation are. Just let me know. चलिए बताएं. इसका आंसर बताएं. The resonance stabilized carbocation are. हाँ जी, जल्दी से बताएं इसका आंसर. Waiting for your answers over here. रेजोनेंस स्टेबिलाइज्ड कौन से होंगे? रेजोनेंस स्टेबिलाइज्ड कार्बोकटाइंस कौन कौन से होंगे? यहाँ पर देखिए, रेजोनेंस स्टेबिलाइज्ड होगा द वेरी फर्स्ट वन, क्योंकि आप यहाँ पर देख सकते हैं द रेजोनेंस इज एक्चुअली गोइंग टू टेक प्लेस. येस, रेजोनेंस पॉसिबल है यहाँ पर. येस, तो इसको हम येस मार्क करेंगे. टॉकिंग अबाउट द सेकेंड वन, अगर मैं सेकेंड वन के बारे में यहाँ पर बात करती हूँ, तो यहाँ पर अगर मैं बात करूँ इसके रेजोनेंस की, कैन यू जस्ट हैव ए लुक. It's CH2 positive over here, fine, and double bond over here. So यहाँ पर भी resonance possible है. In B also the resonance is actually there. Talking about third compound. So over here there is no resonance. अगर मैं इसको यहाँ करती तो आगे तो कुछ shift होगा ही नहीं. तो no resonance, no resonance. Talking about the fourth one. If I just talk about the fourth one, so can you just see? Will there be any resonance? Is this the resonance stabilized carbocation? Mr. Rocker, you are again and again saying about the same thing. Which particular book we need to prefer for PCM, ma'am, crack JEE 2024 and all, something like that. So hold on guys, there will be a session wherein I'll be actually telling you about all these things. So hold on. Now I am in the marathon series, the series which is actually going on. I need to actually talk about the questionnaires over here. So hold on. Fine. So यहाँ देखिए 3 में allylic carbon है. So Radhesham, if there is allylic carbon, so what can we do over here? Is there any possible chance कि यहाँ पर resonance होगा? यहाँ resonance आपको दिख रहा है. क्या ये stable हो पा रहा है? This particular carbocation क्या ये stabilize हो पा रहा है? मैं इस carbon atom की बात कर रही हूँ. Just tell me no. तो यहाँ resonance possible नहीं है. अगर मैं इसकी बात करूँ fourth compound की, अगर मैं यहाँ बात करती हूँ, if I just talk about the fourth compound, so just have a look. It's double bond, this. Okay. So this one I do have. So we do have this and this. So आप यहाँ देखेंगे, आप यहाँ देखिए जो मैं आपको बताना चाह रही हूँ, and it's H over here. Fine. तो यहाँ देखिए ये देखिए यहाँ पर MTP ऑर्बिटल एंड पाई बॉन्ड के बारे में अगर मैं बात करती हूँ, MTP ऑर्बिटल एंड पाई बॉन्ड, फाइन, पाई बॉन्ड p ऑर्बिटल का, दे आर नॉट एक्चुअली इन द सेम फेज. Fine. MTP orbital, if I just talk about the MTP orbital of this carbon atom, and pi bond, okay, they are actually not in the same phase to overlap, hence यहाँ पर कोई conjugation नहीं होने वाला है. Fine. Okay, that's absolutely right. So यहाँ पर it will be 1 and 2 the right answer. 1, 2 are the right answer. Raj Singh says 1, 2 and 4. No, it's not. It's only 1 and 2 basically. Chaliye, let's move ahead and let's talk about the another set of a question, which was the gas, which is a hydrocarbon liberated by the electrolysis of dipotassium succinate is what? Yes, Mr. Bharat, I am actually speaking most of the time in English in this particular session, so I think you need not to worry about the same. Fine, need not to worry about the same. So you need to talk about the gas liberated by the electrolysis of dipotassium succinate. So for this you actually need to know about what? You actually need to know about the formula, the structure of dipotassium succinate. Jayesh says that ma'am it's option number D. Jayesh is saying that ma'am it's option number D. Raj Singh says that ma'am it's option number D. Okay. Priyanshu is saying it's option number D. Why all of you are saying that it's option number D? I'm talking about the electrolysis of dipotassium succinate. How can that be propene? You all are saying it's option number D, D, D. Why it's so? Asta, propene you are saying, why so? Karthik Radhesham has said the right answer. Option number A is the right answer. Let me actually talk about the same. I'm talking about dipotassium succinate. So it will be CH2, COO negative, K positive, and over here it's CH2, COO negative, and it's K positive. Okay, so when it undergoes coal-base electrolysis, if I just talk about coal-base electrolysis, fine, what we're going to have is CH2, COO negative, then it's CH2, COO negative plus twice of K positive, So at anode if I talk about, what is going to happen at anode? It's CH2 COO negative, okay, and it's CH2 COO negative over here. Loss of two electrons, this and this, from here and from both of them. So minus 2 electrons, we are going to get the radical formation CH2 COO radical, and it's CH2 COO radical over here, isn't it? Now what we are going to do is, there will be the removal of 2 carbon dioxide molecules. Yes, there will be removal. How come, ma'am? How we are going to do so? It's C double bond O and it's O radical over here. Fine. Now what's going to happen? This and this, like this. So in a way we are going to have, it's CH2 radical and it's CH2 radical over here, which is actually going to give us ethene. CH2 double bond CH2 we are going to have. Fine. So at anode you can expect that there will be release of carbon dioxide gas and there will be formation of this particular ethene gas. Fine. Okay. Clear? Done? Then are done? That is what I actually want to say. Fine. So at anode we are going to get this, and at cathode there will be evolution of hydrogen gas. Okay, if I just talk about at cathode, what is going to happen, ma'am? There will be evolution of what? Hydrogen gas. So what we do have, it's 2K positive, fine, and it's twice of H2O we do have, fine. So in the end it will be twice of KOH we are going to get, plus the hydrogen gas. Yes, Mr. Shubham, herein I am with the total organic chemistry of 11th and 12th class. Why, Asta, why are you confused over here? It's the simple coal-based electrolysis process. Fine, simple coal-based electrolysis process, wherein we were actually having the dipotassium succinate. Okay, so at anode this is going to happen. This is the very mechanism of coal-based electrolysis, and at cathode hydrogen evolution will be there. Okay, if you are confused a bit, just study again about coal-based electrolysis, Asta. So over here we are going to have, ma'am, you are saying that it will contain 4 carbon atoms. So yes, it is containing CH2COO negative, CH2COO negative. It's actually containing. It is actually containing. Yeah, Vibhanshu, wait a minute. We'll be going far forward. Need not to worry. Fine. Hanji, बताएं. बताएं मुझे आस्था. Just let me know. So यहाँ देखिए, we do have 4 carbon atoms. It's CH2CO negative and CH2CO negative. Fine. So this is potassium succinate. Fine. Yes, I think now you got the point. Yes, yes, dear ones. Chaliye, let's talk about the next question here. Let's talk about the next question over here. No issues, no issues. It happens many times. Vicky, what should I repeat over here? It was basically the main thing you need to know was the structure of potassium succinate. Fine. And then go ahead with the coal-based electrolysis process. You are going to get your hydrocarbon in the gaseous form, which is ethene. So for that particular question, I'm going to mark option number A as the right answer. Option number A. Fine, option number A is the right answer. Chale, let's talk about the major product of the following reaction. Question number 17 in front of us. So it's basically what we are actually having, propylene. Propylene, which is first of all reacting with DCl, one equivalent of its, and then with GI. Fine. So Suresh says that, ma'am, it's option number D. Bhagyalakshmi is saying that, ma'am, it's either B. Okay, Bibekanand is saying it's option number D. Arpita says it's option number B. You need to apply over here Markovnikov rule. You need to apply over here Markovnikov rule. No, Mr. Captain Jack Sparrow. Mechanisms are just for your help. You need to actually go ahead with the right perspective answer. Fine. So over here, if I just talk about this propylene, which is CH3, carbon, triple bond, CH over here. Fine. So what we need to do, first of all, there is one equivalent of DCl. Okay. Applying Markovnikov rule, what initially we are going to get? So it will be CH3. It's carbon over here. It will be Cl over here. Double bond CHD. Again, we are having Di. Again, apply Markovnikov rule. So at the end, we are going to get the product CH3 carbon. I over here, Cl over here, double bonds. Now it won't be double bond, then it will be CHD2. So it's this and this and this and this. You can just go ahead with this particular thing. Easy ho jayega. Fine. So if we are saying this, so it's CH3, CI, Cl, CHD2. Option number D is the right answer. Who is saying option number A and option number B? Himanshu, how you are saying option number A is the right answer, and Mr. Gamer, how you are saying that it's option number B the right answer? Well, the right answer will be option number D only. Anil Kumar, how are you getting option number B? Over here we need to apply what the Markovnikov rule. Yes, D is the right answer. D is the right answer. Fine. Now let me know this particular question. The correct order of the acidic strength, the favorite question of JEE. Okay. This particular type of a question comes. So the correct order in one way or the other, directly or indirectly. Fine. So you need to actually have a focus on these type of the questions. The correct order for the acid strength of the compounds, CH triple bond CH, CH3C triple bond CH, and it's CH2 double bond CH2. So let me know the right answer of this question, wherein Bhagya Lakshmi is saying that it's option number D the right answer. Very good. Very fast. Very good. So literally it's the marathon going on. Literally it's the marathon going on. Yes, it's actually the marathon going on. You are really super fast for attempting these super important 35 organic questions. Okay, so let me tell you how that option number D is the actually right answer for the question asked for. Kaise? Okay, see, let me tell you one thing, that acidic strength is directly proportional to what? Acidic strength is directly proportional to, acidic strength is directly proportional to what? Acidic strength is directly proportional to stability of conjugate base. Stability of conjugate base formed. How we are going to form conjugate base? By the removal of a proton. By the removal of a proton. Absolutely right. Hanji. So yahan par let me actually talk about it. CH triple bond CH. Remove a proton. We are going to get it's CH triple bond carbon negative. Then it's CH3 carbon triple bond CH. Remove the proton. And we are going to get CH3 carbon triple bond carbon negative. Now it's CH2 double bond CH2. Remove one proton and we are going to get CH2 double bond CH negative over here. Okay, fine. So over here this carbon atom do have the negative charge, and this carbon atom is sp hybridized carbon atom. This is sp hybridized carbon atom. sp hybridized carbon atom. So over here percentage S character is more. If percentage S character is more, then the electronegativity of that particular carbon atom will be more. And if that is the case, okay, If that is the case, so the carbon atom which is sp hybridized carrying a negative charge will be highly stable. Is the thing clear? Yes. Fine, it is sp2 hybridized carbon atom. Okay, so carbon atom carrying negative charge, and that too it is sp hybridized. More is the s character, more is the electronegativity. So over here, carbon atom which is sp hybridized carrying a negative charge will be highly stable. So if I just talk about the stability of the conjugate base, this conjugate base is highly stable, followed by this. Why? Between these two, this acetylene is highly stable. Okay, I mean to say the conjugate base of this acetylene is highly stable in comparison to the conjugate base formed from propylene. Reason being, we do have CH3 group over here. It is actually electron donating group having plus I inductive effect. So it is going to destabilize the carbon atom. I mean to say the negative charge on the carbon atom. So if I just compare the stability of the conjugate base between the first one and between the second one, it is the first one which is highly stable, and so is their acidic strength. So the acidic strength of this acetylene is more, then comes propylene, and then comes ethene. Clear? Okay, done. That's absolutely right. Very good, dear ones. So our answer will be option number D, the right answer. Yes, absolutely right. Hanji. Okay, so chale, let's move ahead and let's talk about the next question, which is in front of you. Metallic what? What metallic? Metallic sodium does not react normally with. Metallic sodium does not react normally with. बताएं आप मुझे इसका आंसर. Metallic sodium does not react normally with. I'm getting the answers as option number B, gaseous ammonia, but2-ine, tertiary butyl alcohol, A, B, C and D, all sorts of the answers I'm actually going to get. I'm not going to get, actually I'm getting these all sorts of the answers. Okay. हाँ जी. तो dear ones, क्या कहें इसके बारे में? Let me tell you one thing. For a reaction with sodium metal, for a reaction with sodium metal, the compound should have acidic hydrogen. Compound should have what? Acidic hydrogen. Okay. If I just talk about ethyne, so it's CH triple bond CH. Is the thing clear? Yeah. If I talk about, what should I say? Wait a minute. First of all, let's talk about this ethyne only. So, if I just talk about ethyne, they do have terminal acidic hydrogens. They do have terminal acidic hydrogens, so they will be actually going to react with sodium metal. So it reacts with sodium metal. Yes, reacts with sodium metal. Reacts with sodium metal. But we want what? We want that which do not react with sodium metal. Which do not react with sodium metal. Okay, ammonia gas, if I just talk about, it undergoes a reaction with sodium to form sodamide. Ammonia and gaseous ammonia, I mean to say gaseous ammonia and sodium. I'm repeating it again. Ammonia gas undergoes a reaction with sodium. Okay, so ammonia reacts with sodium to form sodamide, NaNH2, with the release of hydrogen gas. Okay, so these two, they basically react with sodium metal. Okay, because of this acidic hydrogen, it reacts with sodium metal. Fine. Well, if I just talk about but2-ine, if I just talk about but2-ine, just draw the structure of but2-ine. So it's 1, 2, 3 and 4, but2-ine. So in this but2-ine, we do not have acidic hydrogen. Yes, absolutely right. Suresh ने बिल्कुल सही बोला about the tertiary butyl alcohol. It will not show acidic character due to plus I effect of tertiary butyl group. Fine. Absolutely right. So Bhagyalakshmi, it's not D basically. It's C, the right answer, because this but2-ine, okay, it lacks terminal hydrogen atom. Lacks terminal acidic hydrogen atom. So it does not react with sodium. So it does not react with sodium. For tertiary butyl alcohol, as said by, who said the answer? I really don't know who said the right answer for tertiary butyl alcohol. So yes, because of the 3 methyl groups plus I effect basically, So it is not going to show the acidic character. So over here, what I want to say is option number C, the right answer. Metallic sodium does not react normally with but2 ion. Option number C is the right answer. Option number C, gaseous ammonia. Manisha, I just want to talk about the same. Gaseous ammonia, it actually undergoes the reaction with sodium to form the corresponding sodamide. Clear? Astha, Karthik, what happened? I think the things are clear now. Option number C is the right answer. Option C हमारा सही जवाब है. Let's talk about C के बारे में क्या बताऊं? But2 ion है. तो यहाँ पर it is the internal alkyne we are talking about. It do not have the terminal alkyne. If it would have the terminal alkyne group, we would have what? The terminal hydrogen, and that hydrogen would have been very, very acidic. Why that hydrogen would have been very, very acidic? I'm not saying that it would have been very, very acidic. It would be the acidic hydrogens. Why? See, if I just say it's C triple bond, it's H, it's carbon, carbon and carbon. Fine, it's but1 ion. After the removal of the terminal hydrogen atom, we are going to get this particular kind of carbon ion. And this carbon ion, if I just talk about, is highly stable. And if it is highly stable, the corresponding compound will be highly acidic. Why it is highly stable? Because this carbon atom is having negative charge and this carbon atom is sp hybridized. Sp hybridized, I just made you explain in the previous question only. Carbon with a negative charge, sp hybridized, that means it is highly electronegative in nature and it is highly stable. Fine. In internal alkyne, if I talk about, we do not have such type of acidic hydrogen atom. So sodium metal does not normally react with this. Okay, clear? Okay, fine. चलिए. So let's talk about option number C. Option number C की यहाँ पर हम बात करते हैं. The pair of electrons in the given carbon ion, CH3, C triple bond carbon negative. The pair of electrons in the given carbon ion is present in which of the following orbitals? Wow, I did a mistake over here. I should actually have put, I should have actually put this particular question somewhere else. Not consecutively, these two questions should be there. Reason being, the answer you know because I have discussed. So 3 questions are basically in a consecutive manner and the answer of this question I need not to explain you again. It's option number D, the right answer. All of you have actually said the right answer to me. All of you have said the right answer to me. Fine. Thank you so much guys. Thank you so much. चलिए, answer आपने सभी ने अच्छा दिया है. Fine. Okay. Fine. Fine. Okay. So what else? Obviously, ma'am, we need to go ahead on the second question. Not on the second question, the next question herein. The next question herein. So, here is the question. Question number 21 in front of you. Question number 21 in front of you. Just let me know the right answer of this question now. Okay, fine. चलिए बताएं इसका answer. The given reaction requires which of the following reaction conditions? Okay, tell me. Yes, I am actually watching your answers. Watching your answers. Okay. चलिए. Okay. Okay, fine. Hanji, Vivanshu says it's option number D. Karthik says option number D. Nucleophilic substitution reaction, Dow's process. Option number B. Option number D. सब अपने अपने answers यहाँ पर हमें दे रहे हैं. So I just want the right answer of this particular question. Dow's process है ये. Yes, it's the Dow's process we are actually talking about. Yes, of course. Yeah. So यहाँ पर it's the chlorobenzene and we are actually changing it into this particular sodium phenoxide. Sodium phenoxide. Okay. Copper is also used. Yes, A and C options are same. A and C options. अच्छा 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 yes. तो एक में copper हटा देते हैं यार. लो C में option copper का हटा देते हैं. तो अब A और C same नहीं रहेंगे. Well, let me tell you one thing. What is going to happen that over here phenol has been prepared. Okay. At the end product will be the phenol. Phenol is actually prepared here from chlorobenzenes in basically 2 steps. Okay, 2 steps. That's absolutely right or not? Yeah, of course, ma'am, that's absolutely right. Vibhanshu, why they won't be stable? They'll be actually stable basically. It's if I just have Ci2. See, if suppose if I am just saying about previously we did one question of Markovnikov rule wherein on one carbon atom we were having the iodine and on the other we were on the same carbon atom we were having the chlorine, so it was actually stable. So why it won't be? Fine. So chaliye. हाँ जी, चलिए 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 चलिए. ओके फाइन. तो यहाँ पर देखते हैं. इट इज ऑप्शन नंबर डी द राइट आंसर. इट इज ऑप्शन नंबर डी द राइट आंसर. फाइन. सो फर्स्ट क्लोरोबेंजीन क्या होगा? फर्स्ट द क्लोरोबेंजीन इज एक्चुअली हीटेड विद 6 to 8% solution of NaOH. Fine. At a temperature of 623 Kelvin. At what? At under the pressure of 300 atm. So 623 Kelvin temperature, 300 atm pressure, higher pressure, higher temperature, and we are going to form sodium phenoxide. Now this sodium phenoxide is then acidified with dilute HCl to form the phenol. But we need not to talk about that particular thing. Fine. I think after hydrogenation phenol is prepared. That is what I have actually said. Sodium phenoxide is then acidified. Sodium phenoxide is actually acidified with dilute HCl to form further the phenol. But abhi we are not talking about that particular part. We are talking about the very first part, and yes, it is going to take place at 623 Kelvin and 300 atm pressure, which is going to give us the sodium phenoxide. So how the sodium phenoxide we are going to get? So initially what is going to happen is, this is our chlorobenzene. If I just talk about the mechanism over here, it's the chlorobenzene we are having. So it's the hydroxide ion. Yes ma'am, this is the hydroxide ion. Over here we do have H. So what is we are going to talk about? So this is initially we will be actually having a negative charge on this carbon atom and the chlorine over here. Now kind of benzene we are going to get. Not kind of, yes, we are going to get the benzene. Again, it's OH negative. Fine, that is going to approach over here, and like this we will be having. Fine, so what else we will be having? This and this, negative charge over here and OH over here. Clear? Now what is going to happen? H positive, okay, and we will be having this OH. Now this is going to react with NaOH, giving us sodium phenoxide. Okay, fine, clear हो गया ये वाली चीज. अब ये NaOH के साथ में reaction करेगा, and at the end what we are going to get? We are going to get this, and it is O negative, Na positive. Now this sodium phenoxide on acidification with dilute HCl is going to give us again the phenol. Clear here? Fine. चलिए आगे बढ़ते हैं. And herein we'll be talking about the next question. An ethereal solution of 4-nitrochlorobenzene. Ethereal solution of 4-nitrochlorobenzene is treated with metallic sodium. The product formed will be what? Okay. Fine. So an ethereal solution of 4-nitrochlorobenzene is treated with metallic sodium. The product formed is what? Okay. चलिए. Tell me. Just let me know. Hanji. What we are going to get over here? Anyone, any idea? चलिए बताएं. Okay. Cool. Okay. Getting your answers. I'm actually getting your answers as option number B. Yes. Arpita says option number B. Asta says option number B. All of you are actually saying option number B is the right answer. Okay. Anyone else? कोई और answers? Just let me know if there are some other answers. All of you are actually saying option number B is the right answer, ma'am. Okay, fine. तो चलिए. An ethereal solution of 4-nitrochlorobenzene is treated with metallic sodium. The product formed is, obviously, जिन्होंने भी बोला है option number B, well, बहुत सारे लोगों ने option number B को बोला है, and I was actually watching your answers कि yes, you actually talked about option number B. Very good, dear ones. Very good. ठीक है, clear. I got your point. So, what should I say? Yes, option number B is the right answer. 4,4 dinitrodiphenyl is the right answer. Option number B. How come, ma'am? How is possible? How is this possible? It is the Fittig reaction we are going to talk about. Yes, it is the Fittig reaction we are going to talk about, of course. So over here, what we are going to have, it's the 2 moles of this particular compound we are going to have. It's the 2 moles of this particular compound we are going to have. Okay, it is going to react with 2 moles of sodium in the presence of dry ether. That's why we were saying ethereal solution. That's why we was talking about ethereal solution. Ethereal solution of what? Ethereal solution of 4-nitrochlorobenzene. This is what we am talking about. Clear? So at the end, it's basically the Fittig reaction we are talking about, Fittig reaction. So what we are going to have is, it's NO2 over here, then this, and this. 4,4 Woods की first copy है Fittig. Yes, of course, absolutely right. 4,4 dinitrophenyl, absolutely right. So aryl halides, they actually also gives the analogous compounds when they are actually treated with sodium in dry ether, in which the 2 aryl groups are joined together. Hence, it is known to be as Fittig reaction. So option number B, as said by all of you, is absolutely right. Absolutely right. हाँ जी, बिल्कुल सही बात है. तो चलिए, let's move ahead and let's talk about the next question. इसका आंसर दीजिएगा. Among the following statements on the nitration of aromatic compounds. Among the following statements on the nitration of aromatic compounds, the false one is. The false one is. हाँ जी, बताएं. Yes, tell me the right answer. Want to know the right answer of the question? Come on, dear ones, tell me. Okay. Fine. चलिए, आंसर्स मुझे मिल रहे नहीं हैं. ओके, पूनम ने कहा इट्स ऑप्शन नंबर सी. आस्था, अभी आप वुड्स फिटिक पे ही हैं? नहीं भाई, इस पे आइए. कम ऑन, टेल मी द आंसर ऑफ दिस क्वेश्चन. Arpita Singh is saying is option number A. Riddhi says option number D. Nitration is an electrophilic substitution reaction. हमें क्या बताना है? The false statement बताना है. Please read it carefully. We want to talk about the false statement. We need to talk about the false statement. हाँ जी. The rate of nitration. The rate of nitration. सबसे पहले एक बात बताइए, nitration में which particular electrophile we are going to get? Which particular electrophile we are going to get in nitration? Which particular electrophile we are going to get in the nitration process? ये बताइए पहले मुझे, सबसे पहले आपको मुझे यही बताना है. उसके बाद we'll be talking about NO2 positive. It's NO2 positive and not NO positive. It's NO2 positive. Absolutely right. So this is the electrophile we are going to get in nitration process, and this particular electrophile is going to react with what? Benzene as well as with hexadeuteurobenzene. So can you tell me what is the, if I just talk about, what should I say? In rate determining step, can you just tell me one thing? If I just talk about the rate of nitration, okay, that means I'm talking about the slowest step, the rate determining step. So what is going to happen in rate determining step? Can anyone tell me? In rate determining step, is there the removal of H positive ion that is going to take place? Yes, हर्ष ने बिल्कुल सही बोला. आइसोटोपिक इफेक्ट के बारे में हम यहाँ बात करेंगे. चलिए, so अब यहाँ हम क्या बात कर रहे हैं? Hexadeuteurobenzene. What is hexadeuteurobenzene? What is hexadeuteurobenzene? This is hexadeuteurobenzene. This is hexadeuteurobenzene. Okay, and the normal benzene, you all of you know, this is the normal benzene. Okay, so basically this hexadeuteurobenzene is what? It is an isotope. This is what it is, an isotope. It is the isotope of benzene basically. It is the isotope of benzene. Clear? Wherein all the hydrogen atoms are replaced by deuterium. Okay. Now listen to me very carefully. Removal of hydrogen atom. Removal of hydrogen atom. Removal of hydrogen atom does not take place. Does not take place in rate determining step. So kinetic isotope effect is absent over here. Kinetic isotope effect जो है वो यहाँ पर absent रहेगा basically. Fine. Well, if I just talk about the rate determining step, so in rate determining step what we are having, this is benzene. The electrophile NO2 positive is approaching it, and hence what we are going to get, it's basically the slow step, rate determining step, and hence this is what we are going to get. This is what we are going to get. It's NO2 over here, H over here, and positive charge over here. So in rate determining step there is not the removal of the hydrogen atom. Fine. So we can say kinetic isotope effect is absent. Fine. Now what I want to say, the rate of nitration. The rate of nitration basically of deuterated benzene. Rate of nitration of deuterated benzene. Suppose if I just talk about the deuterated benzene. In this deuterated benzene also, if I just talk about the rate determining step, just have a look. The slow step, rate determining step, we are going to get this. What we are going to get, it's D over here, NO2 over here, positive charge over here. Yes, it was D over here. Wait a minute. It's D over here, but with a positive charge over here. It's D, 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 and D. But what is actually happening in this rate determining step, there is not the removal of hydrogen nor the removal of deuterium. So we can say that the kinetic isotope effect is absent over here. Now the rate of nitration of deuterated benzene is basically same that of the benzene, normal benzene. Fine. Now see, they both are actually undergoing nitration, okay, using the nitrating agent. So we can say the rate of nitration in deuterated benzene and in the normal benzene is the same. Reason I have told you that in rate determining step there is not the removal of hydrogen as well as of deuterium. That is what I want to talk about. So over here the false statement, if we want to talk about the very first statement, let's talk about the first statement. Rate of nitration of benzene is almost same as that of hexadeuterobenzene. Yes, it's actually true. Talking about the rate of nitration of toluene is greater than that of benzene. If I just talk about toluene, this is toluene, okay, and this is benzene. Okay, so over here electrophilic, it's basically which particular reaction we are talking about? It's basically electrophilic substitution reaction we are going to talk about. Okay, electrophile is going to approach. So for an electrophile to approach, our particular reactant should have high electron density. So if I compare toluene and benzene, it's the toluene having the higher electron density. So we are going to say that the rate of nitration of toluene is greater than that of benzene. Absolutely right. This is absolutely right. So it is actually true statement. But saying that rate of nitration of benzene is greater than that of hexadeuterobenzene, it's actually false. And the reason why it is false, I have actually told you. Nitration is an electrophilic substitution reaction. Yes, it's true. It's the electrophilic substitution reaction. So we want to select the false statement. We'll be saying option number C is the right answer. We'll be saying option number C is the right answer. Okay? Done, done, done. Anyone, any sort of doubt? No doubt. चलें आगे बढ़ें. Okay, got it. चलिए. Let's talk about the next set of a question. Herein we'll be talking about the preparation of bakelite proceeds via the following reaction. The preparation of bakelite proceeds via the following reaction. Now just tell me, इसका क्या answer होगा? What will be the answer of this particular question? हाँ जी, tell me. बताएं इसका आंसर क्या होने वाला है? What is going to be the answer of this particular question? So if you actually love the session, if you actually find that this particular session is really helpful for you in understanding some of the concepts you were actually having the problem, hit the like button, subscribe the channel, dear ones. Okay. So formation of bakelite, if I just talk about, it's the phenol formaldehyde resin. Okay, so it's the phenol plus the formaldehyde. Okay, they undergoes reaction in acidic or basic medium. Initially we are going to write what? Initially we are going to write orthohydroxybenzyl alcohol. Initially what we are going to get, orthohydroxybenzyl alcohol as well as para-hydroxybenzyl alcohol we are going to get. Afterwards, in a way we can get a linear polymer also, which is known to be as Novolac, used in paints. And over here we can also get the cross-linked polymerization also, which will lead us in the formation of what? The formation of bakelite. So in a way, orthohydroxybenzyl alcohol, n times of orthohydroxybenzyl alcohols and n times of para-hydroxybenzyl alcohol, they undergoes polymerization. Okay, followed by dehydration, removal of water molecule, and hence at the end we are going to get what? We are going to get the cross-linked polymer known to be as bakelite, thermosetting polymer basically. Fine. So over here, if I just talk about what is initially going to happen, what is the very first thing going to happen over here? Motive of life नहीं समझ में आया. यहाँ देखिए सबसे पहले it's the electrophilic substitution that is going to take place, which will be giving us orthohydroxybenzyl alcohol as well as para-hydroxybenzyl alcohol. When the orthohydroxybenzyl alcohol reacts and undergoes polymerization with para-hydroxybenzyl alcohol, there will be dehydration that is going to take place. So over here it's option number A, the right answer, electrophilic substitution, and then followed by dehydration. Okay, so it's the phenol, that is what I'm having with, okay, phenol plus HCHO. Okay, so if I just take the acidic medium, HC double bond O and H over here, it's the H positive. So what it will be, if I just talk about the same over here, it's CH2 double bond OH positive. This is what I will be having. Now what else? Now the phenol, if I talk about, phenol is going to react with this particular electrophile CH2 double bond OH positive over here. So it shifts over here like this, fine. And this and this is what initially we are going to have. This is OH over here and it's H over, it's OH over here, fine, and it was H over here and it's CH2OH over here, fine. So we were actually having a positive charge on this carbon atom, removal of H positive, and at the end we are going to get, it's orthohydroxybenzyl alcohol. Okay, and the major product will be para-hydroxybenzyl alcohol. Okay, this is what we are going to get. So this is electrophilic, substitution that is actually taking place. Now n times of this orthohydroxybenzyl alcohol and n times of this para-hydroxybenzyl alcohol, they undergoes polymerization. Okay, followed by what? Obviously Manisha is saying condensation, so that means over here there will be removal of water molecules, so we can say followed by dehydration also, and hence we are going to get what? Cross-linked polymer, the bakelite. Fine, so we'll not go in details. We'll be talking about that. Option number A is the right answer. It's option number A that is the right answer to this particular question. Okay, ठीक है, clear है, चलिए, option number A. So all the other answers, they are not actually the right answer. It's electrophilic substitution followed by dehydration. तो चलिए, let's move ahead and let's talk about the next set of a question. अरे वाह, good question. आप solve कीजिए, इतने में पानी पी लेती हूँ. Okay, just solve the question and till then I'll have my water. Okay, so Aakash is saying कि ma'am इसका answer है, the answer to this particular question is option number C. How to actually make organic chemistry the strongest one while practicing it? First of all, you need to know each and every concept. You should be thorough with the concepts and then solve the questions based on them. Then solve the mixtures of the questions And yeah, you will be actually going through organic chemistry then. Astha, Aakash, Vivekanand. Acha, Vivekanand is saying it's option number C. Astha says it's option number D. Arnab says option number D. Vicky says option number D. Okay. Okay. Fine. I'm getting your answers. So, chaliye. So, what should I say about the same? क्या कहना चाहिए मुझे? क्या कहना चाहिए? कि ऑप्शन नंबर डी होगा सही, कि ऑप्शन नंबर ए होगा या बी होगा या सी होगा. देखिए, at the end what we are going to get is that this at the place of nitro we are having OH, and at the meta position we are having chlorine. At the meta position we are actually having chlorine. Okay ma'am, so what should we say? Nitro group is a meta directing group. So it is better that initially we do have what? We should have a reagent because of which we are going to have the chlorine at meta position. So I'll say one particular thing over here. And what is that one particular thing, ma'am, you want to actually talk about? See, this Fe in presence of HCl is actually the reducing agent which is going to reduce NO2 to NH2. Now this NH2 is not electron withdrawing group, rather it is electron donating group, or you can say it's I'll say it's not meta directing group, rather it is ortho and para directing group. So if initially we are using FeHCl, no problem in that. NO2 will be initially getting converted into NH2, and then if we are actually taking chlorine or something else, so basically NH2 is ortho and para directing group. So it's option number A out of the race. Even if I talk about B, it's also out of the race. We are left with option number C and D. So in option number C and D, initially we are doing what? Chlorination in presence of FeCl3. Absolutely right. The incoming electrophile, which is chlorine, is going to attach at meta position because nitro group is meta directing group. So initially, if I just take this nitrobenzene, NO2, reacting this nitrobenzene with chlorine in presence of FeCl3, we are going to get our meta substituted product, chlorine at this position and NO2 over here. Fine, that's absolutely right. Now, if I just want to do one thing, it's NaNO2 HCl in 0 degrees Celsius. See, it's the amine which when reacted with sodium nitrite in presence of HCl, then we are going to get a disonium salt. So now we can do one thing. Now when it reacts with Fe in presence of HCl, dear ones, so we are going to get NH2 over here. It's the reduction that is taking place and the chlorine over here. Now when the reaction is with sodium nitrite at 0 degrees Celsius in presence of HCl, what we are going to get? The disonium salt we are going to get, which is N2 positive and Cl negative. N2 positive and Cl negative. Cl negative and Cl over here. Now when this disonium chloride undergoes acidic hydrolysis, okay, when it undergoes acidic hydrolysis is H2O in the presence of acid. Obviously, what is going to happen? The nitrogen molecule, it escapes as nitrogen gas, and the OH group of H2O attacks the vacant site left after the removal of nitrogen gas. This results in the formation of phenol. And here we are with the desired product. So we'll say that it's option number D the right answer. It's option number D the right answer. Absolutely right. Yes, Manisha, Astha, it's option number D the right answer. So don't get actually, I want to say, just don't change your path. Fine, be on the same path. Fine, be on the proper path for this particular question to have the desired product. Yes, okay, Vicky, if you feel that these questions are very easy, really very good. That means you have really prepared well for the examinations. Yes, ma'am. So, chaliye, let's talk about the next question. Ceric ammonium nitrate. Wow. Ceric ammonium nitrate test is for what? You all know. And we do have chloroform in the presence of alcoholic KH. It's the reagent of a very famous reaction. They are used in the identification of functional groups present in dash and dash. It's a very easy question. Aakash says it's option number A. Aakash, are you confused? It's option number A or it's option number D? Now Aakash has changed and it says that it's option number D. Okay, it's option number D. Fine. तो क्या कहना चाहिए इस पर्टिकुलर क्वेश्चन के लिए हमें? What should we say? Steric ammonium nitrate, and it's basically chloroform in the presence of alcoholic KOH that are used for the identification of the functional groups present in dash and dash. C and D same hai? C and D are not same. It's the amine we have said and then alcohol, and in D we are saying alcohol and then amine. D पे lock किया जाए. Shall we lock option number D? Yes, it's option number D the right answer, because steric ammonium nitrate, if I just talk about, it's the test for alcohols. It's basically the test for alcohols, twice of ROH. Talking about steric ammonium nitrate, it's NH4 whole twice CeNO3 whole 6. Fine, which is going to give us its ROH whole twice CeNO3 4 plus twice of NH4NO3 we are having. So this is the red color compound. That is what we are going to get, red color compound, which actually detects and says the positive test for alcohols. So steric ammonium nitrate test is basically for alcohols. It's basically for alcohols. Now talking about carbylamine test. The famous reagent is chloroform in the presence of KOH. Yes, absolutely right. So if I just talk about carbylamine test, it's basically for 1 degree primary amines, aromatic as well as aliphatic. Okay, so it's RNH2 we are having, the primary amine, okay, which when reacted with CHCl3 in presence of KOH and heated up, we are going to get what? A foul smelling compound, isocyanide R and positive triple bond C negative. Clear? Plus thrice of KCl plus thrice of H2O we do have with us. Clear? So over here is it's basically the test for primary aromatic or aliphatic amines, carbylamine test. Okay, so it's the alcohol for steric ammonium nitrite and the amine for CHCl3 in presence of alcoholic KOH. Yes, absolutely right, Asta. Bilkul. Absolutely right. So chaliye, let's move ahead and let's talk about the next question. And here is a good question in front of you. Kafi acha question hai. The correct sequence of reagents for the following conversions will be. The correct sequence of reagents for the following conversions will be. Hanji, just tell me, kya hoga iska answer? Yes, tell me. Okay. Hanji. Correct sequence of reagents for the following conversions. Motive of life, how you can become good in your chemistry as well as physics. See, first of all, you need to learn from the basics. Okay, make your concepts the stronger one. Okay, go through the concepts, have your command on the concepts and solve the questionnaires related to them. Once you have done this particular thing, now you can go ahead with the standard books, practice those standard books, and you will be actually mastering the chemistry as well as physics. Okay, you need to manage your time. You need to manage your time basically. That is what I want to make clear. ठीक है? Clear है? हाँ जी मैम. So motive of life ने कहा option number C है इसका answer. It's the ammonical silver nitrate test we are doing. Then the esterification and then the Grignard reagent is being actually used. Fine. Harsh Kumar says it's option number B. Harsh पहले आप check कर लीजिएगा. आकाश आप check कर लीजिए. कार्तिक भी check कर लें. आयुष कुमार, you are actually confused whether option number C is right or not. Well, it's the tolerance test followed by esterification, and then we will be talking about the Grignard reagent. Hardik says it's option number A. Supratim says option number C. Dear ones, I give you 1 minute time over here. Please solve it nicely. Otherwise, you are going to do a blunder for this particular question. Aastha ne bilkul sahi kaha. Tolerance test followed by esterification, and then we are going to use Grignard reagent. Okay, fine. Grignard कैसे होगा Grignard reagent पहले? If you are going to do Grignard reagent पहले, तो see, you are going to get this from this particular carbonyl group. You no doubt you are going to get this OH and CH3. But what about this CHO, dear one? What about this CHO? Are you going to get these two methyl groups at this particular place? Kartik, you are actually determined on option number C. क्या मैं आपको option number C lock कर दूं कुणाल and कार्तिक का? बताएं मुझे. Solve this and then come to me saying कि मैम option number C right है या option number D right है. Initially हम सबसे पहले CH3MgBr को use नहीं करेंगे. ये wrong है. Fine. तो option number Okay. I was confused. Option number C. ठीक है. Okay, option number C. Fine. So option number D भी हमारा out of the race हो जाएगा. Between B and C we need to judge it. So आस्था ने बिल्कुल सही बोला था. Let me actually talk about the same. So see, we do have this particular compound with us, and it's CH double bond O over here. Fine. Okay. So when we are actually talking about tolerance test, first of all we are going to talk about tolerance test. Okay ma'am, tolerance test. So tolerance test के बारे में we discussed over here. Fine. So tolerance test है, so it is going to actually oxidize this aldehyde into the corresponding acid. Yes ma'am. ठीक है. Which is going to give us the silver mirror test. Yes ma'am. C double bond O and OH. This is what we are going to get. Fine. Yes. This is what initially we are going to get. So now if I do esterification, CH3OH in the presence of acid, okay. So this is the esterification going to take place. So alcohol plus acid gives us ester. Alcohol plus acid gives us ester, okay. We'll be doing this also. It's C double bond O and OCH3. This is what we are going to get. Fine. Now what you are supposed to do is, now go ahead with the Grignard reagent. So initially, if I just talk about Grignard reagent, let's take 2 moles of Grignard reagent. Initially, let's take 2 moles of Grignard reagent. 2 moles of Grignard reagent. Okay. So one will go over here and the other one will go on this carbon atom like this. Okay? Clear? Okay ma'am, done. So what we are going to have is, it's O negative and it's CH3. It's O negative MgBr positive, delta positive, and it's delta negative. Fine. Okay. And this is what we are having. It's carbon. Okay. It's OCH3 over here. It's O negative MgBr positive, delta positive, delta negative, and it's CH3 over here. Now what we can do? Okay. So H positive hydrolysis if I just do. Okay, so it's OH CH3 over here we are going to have. Fine ma'am. What else we need to talk about? Wait a minute. It's basically it's CH3 over here, it's OH over here, and CH3 over here. Fine. Now what else ma'am? Yes, H positive is going to come over here. Fine. And we will be actually having, it's this OH over here, CH3 over here, then it's carbon OCH3, CH3, okay, and it's, oh, wait a minute, we did a mistake over here, yes or no, if we are actually talking about, see, wait a minute, what I want to clear it over here is, yes, now see, it goes over here like this. This OCH3 will be removed, so it's OCH3 leaving out. At the end what we are having, can you just have a look? This, it's OH, it's CH3, it's carbon double bond OH, and it is CH3 we are having. Removal of this hydrogen. Now we are going to remove this hydrogen minus H positive. So when we do this removal of the hydrogen, we are going to get a ketone over here like this. Okay, now we will be using 1 more mole of Grignard reagent. 1 more mole of one more mole of Grignard reagent we are gonna use. Okay, so it's CH3 delta negative, MgBr delta positive. Again the carbon is going to come over here like this, followed by acidic hydrolysis, and at the end we'll be having our desired product, which looks like it's OH over here, CH3 over here, it's OH over here, CH3 over here, and CH3 over here. क्लियर है? समझ में आ गया आपको? ये क्लियर हो गया है आपको? Yes. 3 moles of Grignard reagent they are going to be used over here. 3 moles of Grignard reagent वो यहाँ पर use होंगे. 3 moles of Grignard reagent वो यहाँ पर use होंगे dear ones. ठीक है? Done, done, done. Okay. Yes. So एक तरह से it will be option number C जो आस्था ने बोला. It was really very good. Well, सभी ने इसका आंसर सही दिया है. कुछ स्टूडेंट्स ने गलत दिया था. They might have been confused at that particular point. Fine. तो चलिए let's move ahead and let's talk about this particular question now. The link of this particular lecture will be actually given in the description box, and there is by the name of Smart Playlist. Go ahead with this particular thing and you will get the notes. Fine. So the increasing order of reactivity, if I just talk about the increasing order of reactivity of the following compounds in the nucleophilic addition reaction is propanol, benzaldehyde, propanone and butanone. These are the compounds given to us. We need to talk about the increasing order of reactivity of the following compounds in a nucleophilic addition reaction. Nucleophilic addition reaction. Okay. So Amar has said it's option number B, ma'am. It's option number B, ma'am. Okay, so Amar, you are saying it's option number B, B for Byju's. Yes, B for Byju's. So over here, we are talking about the nucleophilic addition. Okay, we are talking about nucleophilic addition. The electron density at carbonyl carbon, if it get increased, the electron density at carbonyl carbon, if it get increased, okay, how it is going to increase? With the increase in plus I effect, then what is going to happen? The chances of attack of nucleophilic addition decreases. ठीक है? अगर carbonyl carbon पे we are going to increase the electron density with the help of plus I effect of the alkyl groups attached to it, the chances of attack of nucleophilic addition will be decreasing. Fine. So if I just talk about propanol, okay. If I just talk about propanol, no. It's basically propanol given to us. Okay, fine. Propanol CH3, CH2, and it's CH double bond O. Then we do have benzaldehyde. So this is benzaldehyde we are having, CH double bond O. Then it is propanone and butanone. So this is propanone. I'm talking about butanone. So it's CH3, C double bond O, CH2 and CH3. This is butanone. Fine. And aldehydes are more reactive than ketones. Absolutely right. So if aldehydes are more reactive than ketone, that means these two aldehydes are more reactive towards nucleophilic addition in comparison to the ketones. One thing. Between these two aldehydes, which will be more reactive towards nucleophilic addition, acetaldehyde, not acetaldehyde, sorry. It's the propanol. It's the propanol that will be more reactive than benzaldehyde. Why? This is because the carbon atom of the carbonyl group in benzaldehyde, the carbon atom of this carbonyl group, अगर मैं इसको बहुत अच्छे से लिखूँ, it's C double bond O and H. So the carbon atom of the carbonyl group in benzaldehyde, it is less electrophile. It is less electrophilic. It is less electrophilic than the carbon atom of the propanol, then the carbon atom of the carbonyl group in propanol. Reason क्या है? Over here, if I just talk about this carbon atom, if I just talk about this carbon atom, okay, fine. How it is less electrophilic in nature? Suppose this shifts over here and this carbon atom is having the positive charge. Now the positive charge on the carbon atom spread throughout the molecule. Hence this particular carbon atom, I'll say it's less electrophilic in nature. The things have been clear to you or not? Just let me know. Yes, ma'am, the things have been clear to us. So if the things have been clear to you, it's C double bond O and H over here. Fine. Okay. Clear. तो यहाँ पर यस एब्सोल्युटली आस्था ने बिल्कुल सही बात बोला, यहाँ पर डीलोकलाइजेशन होगा। और अगर यहाँ डीलोकलाइजेशन हो रहा है तो ऑब्वियस सी बात है यहाँ पर न्यूक्लियोफिलिक एडिशन जो है इट विल बी लेस रिएक्टिव। न्यूक्लियोफिलिक एडिशन यहाँ कम होगा इन कंपैरिजन टू न्यूक्लियोफिलिक एडिशन, न्यूक्लियोफाइल कैरिंग द नेगेटिव चार्ज। सो nucleophile wants a reactant which is actually having less electron density. So if I just compare the electron density of this propanol and benzaldehyde, the electron density in propanol is less in comparison to benzaldehyde. The reason I have just told you. Okay, talking about acetone and this is butanol, the reason is same, that if we are increasing the plus I effect, inductive effect, so over here the inductive effect is actually increasing. Why? Because we do have the alkyl groups on both the sides of the carbonyl group. So in between acetone and butanol, it's the acetone which is having less alkyl groups. So if it is having less alkyl groups, obviously the plus inductive effect over here on the carbonyl will be less, and in comparison to butanol, the nucleophilic addition will be more at acetone. I think the things have been clear to you. So the electron density at carbonyl carbon, it is going to increase with increase in the plus I effect. As a result, the chances of nucleophilic attack, the chances of attack by the nucleophile will decrease. So it will be this. This is actual में the order. Okay, Karthik. What? Okay, fine. Chaliye. So over here, what will be the answer? Propanol, then benzaldehyde, propanol, and it's basically butanol. Option number B is the right answer. हाँ जी, समझ में आया? Do you get this particular thing? Dear ones, come on. Are you in your activated state? Are you energetic? The energy is maintained or not? Have the water. Okay, have water. Drink water and be in your activated state. Fine. We are good to go with few more questions. Fine. So yes. Chaliye, let's talk about this particular question. Wow, it's very easy lemon squeezy question. The Josh should be high, Mr. Vicky. The Josh should be high. Fine. So consider the reaction given below and you need to identify why. Why? Okay, it's the nitrile we are actually having with us. This is the nitrile we have with us, isn't it? Yes, ma'am, this is the nitrile. Okay, and it's diisobutyl aluminium hydride. Diisobutyl aluminium hydride we do have. Okay, followed by hydrolysis. Then what we are going to get? What will be YCHO? It's a really easy question, isn't it? Yeah, it's straightly coming from your NCERT. So initially RCN, when reacts with diisobutyl aluminium hydride, when RCN, okay, it reacts with diisobutyl aluminium hydride, we are going to get imine first. RCH double bond NH we are going to get. This is imine. This imine when reacts with H2O is going to give us RCH double bond O. Clear? Clear हो गया ये वाली चीज आपको? Yes ma'am, it's absolutely clear. So if it's absolutely clear, herein we'll be saying it's option number B nonetheless. कोई शक? No शक. Okay. तो चले move ahead. चलिए ma'am, let's move ahead and let's talk about something else. Fine. Herein, what I said, it's option number B. Okay, fine. Moving ahead and let's talk about this particular question now. Chaliye, which one of the following reactions will not form acetaldehyde? Acetaldehyde कौन नहीं बनाएगा यहाँ पर? High definition crystal clear. Okay. It should be high definition crystal clear. Fine. So over here, it's the 4 reaction given to us and the question is asking us which of the following reaction will not form acetaldehyde. कौन इनमें से acetaldehyde नहीं बनाने वाला है? तो देखिए, if I just talk about CrO3H2SO4, हाँ जी, CrO3H2SO4. So this particular reagent, if I just talk about, this is what? This is Jones reagent. Is this the Jones reagent we are talking about? CrO3H2SO4 if we are talking about. Is this the Jones reagent we are talking about? Yes, ma'am, this is the Jones reagent. It's a strong oxidizing agent. If it's a highly strong oxidizing agent, it is going to actually convert this alcohol into corresponding acid, and we are going to get CH3COOH indeed. Okay, so it's CH3COOH we are going to get through this Jones reagent. This is Jones reagent. Fine, so alcohol converted into acid. Okay. So basically, if I just talk about Jones reagent, it is a solution of chromium trioxide in dilute sulfuric acid. Fine. Is the thing clear? Hanji bataएं. Fine. So you can just say it's aqueous CrO3 H2SO4 in the presence of acetone. You can just talk about, yeah, Asta. Okay. No issues in that, Asta. इसमें कोई दिक्कत वाली बात ही नहीं है. Simply it's CrO3 H2SO4 आपको initials दे दिए गए हैं. Fine. No issues. It is actually going to behave as Jones reagent. Fine. Now talking about the next one. It's CH2 double bond CH2 plus oxygen in the presence of palladium 2 catalyst or copper 2 catalyst and reacting with water H2O. So over here what we are going to get is it's CH3 CHO we are going to get. Fine. This is what we are going to get, acetaldehyde. Fine, yes, this is the acetaldehyde we are going to get over here. Even this copper, if I just talk about it at 573 Kelvin, it is going to behave as an oxidizing agent only. Fine, so herein we are going to get CH3CHO. But it is not as strong oxidizing agent as this Jones reagent was. Fine. Okay, fine. Anhydrous you are talking about. Okay, fine. So यहाँ पर if I am talking about, if you are saying it's aqueous, if I am saying if it is aqueous CrO3 in the presence of H2SO4, because I am taking dilute H2SO4, so yes, it's the Jones reagent. So over here anhydrous is not yeah, wait a minute, Asta. You are, yeah, I got your point. Since I'm saying that Jones reagent is basically the chromium trioxide and dilute H2SO4, basically it's the aqueous thing. For anhydrous it will be written. Fine. Well, I'll talk about the same. Wait a minute, I'll be talking about the same. Wait a minute, just wait a minute. Okay, I'll be talking about the same. So over here, okay, fine. So over here, let's talk about the D option first of all. Chaliye. We'll be talking about the same. So over here, it's CH3CN. Wait a minute. Yeah, of course, Asta आप सही कह रहे हैं. It's CH3CN and we are using diisobutyl aluminium hydride and H2O. Again, it will be CH3CHO over here. Thank you so much, Asta. Thank you so much, yeah. So over here, see, chromium trioxide is basically what? Chromium trioxide is basically a strong oxidizing agent which is not soluble in most of the organic solvents, and it actually tends to explode in the presence of organic compounds. Fine, okay. In the presence of organic compounds and the solvents. So in water, basically it forms chromic acid and anhydrides. Clear hai wali cheez. Now, what we actually talk about, that when chromium trioxide is actually present in the anhydrous medium. When the medium is anhydrous, that means there is no presence of water. Then basically it is used in the isolation of aldehydes. I will repeat it again. I will be repeating it again. Fine. So, when chromium trioxide is actually taken in the anhydrous medium, that means there is no water presence, then it is actually used in the isolations of aldehyde from alcohol. Okay, but when it is dissolved in pyridine and HCl, just have a look, it forms pyridinium chlorochromate, which is a better reagent basically. Fine. Is the thing clear now, Asta? Is the thing clear to you now? Hanji, Asta, bataiye. Just let me know. So, a better reagent for what? A better reagent for oxidation of primary alcohols. primary alcohols to aldehydes. In a good yield, if I just talk about, is basically pyridinium chlorochromate, PCC, a complex of what? Chromium trioxide with pyridine in HCl. Clear हो गया ये वाली चीज? I think this is actually written in the NCERT text. ये NCERT text में लिखा हुआ है. Fine. Done है ये वाली चीज. So यहाँ पर what I was saying is that it's, if I just take it's RCH2OH and if I'm taking CrO3. Okay, so CrO3 in anhydrous medium is used as what? The oxidizing agent for the isolation of aldehydes. From what? From what? Isolation of aldehydes from the alcohol. So we are going to get its RCHO. Anhydrous. 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 Fine, clear है? Clear है? हम वहां पर मिस्टर ABC, हाँ ये बहुत सिंपल रिएक्शंस हैं, आपको एनसीईआरटी में मिल जाएगी, ठीक है. सो एबीसी मैम H2SO4 भी तो वाटर एब्जॉर्बर है, ठीक है. आप कह रहे हैं डिहाइड्रेटिंग एजेंट है, लेकिन हमने वहाँ डाइल्यूट H2SO4 लिया, कॉन्क H2SO4 नहीं लिया है. जॉन्स रिएजेंट के अंदर इट्स क्रोमियम ट्राइऑक्साइड विद डाइल्यूट H2SO4 वी आर एक्चुअली टेकिंग, ठीक है. सो एनहाइड्रस के अंदर ये RCHO तक ही रिएक्शन रुक जाएगा, लेकिन अगर हम बात करते हैं CrO3 विद H2SO4, वो भी डाइल्यूट कंडीशंस हैं, एक्वस कंडीशंस हैं, तो हमें यहाँ पर देखिए इट इज बिहेविंग एज अ स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट, ठीक है. डन. आस्था, दैट्स क्लियर एंड थैंक यू सो मच आस्था. ओके, थैंक यू सो मच गर्ल, थैंक्स अ लॉट. चलिए, अदरवाइज हाँ थोड़ा प्रॉब्लम हो जाता. Fine, thank you so much. चलिए, I think I've made the point clear about the aqueous and the anhydrous thing, and here we move ahead and let's talk about the same. So over here, yes, we were on the, I didn't talked about the right answer. Which one of the following reactions will not form acetaldehyde? Is option number A the right answer? It's option number A the right answer. ठीक है, चलिए herein we are going to talk about the next set of a question. Which of the following reagents is used for the following reaction? Fine, इसके बारे में बताइएगा मुझे. Just let me know. Which of the following reagents is used for the following reactions? यहाँ हमने एल्केन लिया है and we are actually converting the alkane into aldehyde. वैसे इट्स अ वेरी बेसिक रिएक्शन, यू माइट ऑल नो, ये एनसीईआरटी के अंदर एज इट इज गिवन है. सो हेयर इन यू कैन जस्ट सी कि किस तरह से एनसीईआरटी के डायरेक्टली क्वेश्चंस यहाँ पर आ रहे हैं, डायरेक्ट क्वेश्चंस यहाँ पर आ रहे हैं, है कि नहीं? यस मैम, एब्सोल्युटली राइट. सो यहाँ पर इट्स द एल्केन वी आर टॉकिंग अबाउट फर्स्ट ऑफ ऑल एंड कन्वर्टिंग इनटू प्रोपेनल्डिहाइड, प्रोपेनल यू कैन जस्ट टॉक अबाउट. फाइन, हाँ जी बताएं मुझे. तो सिंपल एक आपको रिएक्शंस बताऊं जो हमें एनसीईआरटी में गिवन है, ठीक है. सो देखिए इट्स ट्वाइस ऑफ CH4 प्लस ऑक्सीजन और हम इसको रिएक्ट कर रहे हैं कॉपर के साथ एट अबाउट 523 केल्विन एट 100 atm प्रेशर. सो वी आर गोइंग टू गेट एल्कोहल ट्वाइस ऑफ CH3OH. अगर हमने वही मीथेन लिया वापस से एंड ऑक्सीजन के साथ में रिएक्शन कराया इन द प्रेजेंस ऑफ मोलिब्डेनम ऑक्साइड MO2O3, सो हमें यहाँ मिलेगा HCHO प्लस H2O हमें यहाँ मिल रहा है. सिमिलरली अगर मैं लेती हूँ यहाँ पर CH3 ये एल्केन लेती हूँ और इसका रिएक्शन मैं ऑक्सीजन के साथ कराती हूँ इन द प्रेजेंस ऑफ मैंगनीज एसीटेट, आप यहाँ पर देखेंगे वी आर गोइंग टू गेट इट्स ट्वाइस ऑफ CH3 COOH प्लस ट्वाइस ऑफ H2O. क्लियर है ये वाली चीज. सो याद रखिएगा, एक और चीज मैं आपको बताना चाहती हूँ, हायर एल्केन्स ऑन ऑक्सीडेशन इन प्रेजेंस ऑफ मैंगनीज एसीटेट दे गिव अस फैटी एसिड्स. फाइन. सो यहाँ पर ये वो रिएक्शंस मैंने आपको बताए हैं, द रिएक्शंस गिवन इन the reactions which have been given to us in the NCERT. So based on this particular thing, what we can say, if it is alkane and we want to convert it into aldehyde, the answer will be molybdenum oxide. Fine. Manganese acetate की अगर हम बात करते हैं, so it is actually transforming the alkane, corresponding alkane into the acid. Fine. क्लियर है. इफ वी आर टॉकिंग अबाउट कॉपर एट हायर टेम्परेचर एंड प्रेशर जो कि हमने लिया, सो इट इज एक्चुअली कन्वर्टिंग द एल्केन इनटू द एल्कोहल. इफ आई टॉक अबाउट पोटेशियम परमैंगनेट, इट्स एक्चुअली द ऑक्सीडाइजिंग एजेंट, सो ऑब्वियसली इट विल नॉट stop the reaction at aldehyde point, rather it will be taking it further and will make it as acid. Clear? Done. Clear? Okay, so it's option number C, the right answer. Done, 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 done. So it's option number C, the right answer. Let's move ahead. I hope there won't be any doubt till now. The doubts have been cleared for all of you guys over here. Just let me know. Come on, dear ones. Hanji, bataye mujhe. Are the things clear to you? Yes or no? Tell me. Hanji. Chale, aage badhe. Let's move ahead. Is it HDCC? I mean to say high definition crystal clear हो गया आपको? आस्था, कार्तिक, मनीषा, आयुष, राधेश्याम. ओके, चलिए चलिए चलिए. अरे, question is this only. Which among the following chemical test? Okay, fine, Karthik, fine. Which one among the following chemical test is used to distinguish monosaccharides from disaccharides? Monosaccharides को disaccharides से हम कैसे distinguish कर सकते हैं? From which of these particular test? From which of these particular test? चलिए बताएं मुझे आप. चलिए, monosaccharide का कोई example दे दीजिए, disaccharides का कोई example दे दीजिए. It's just a random question I'm asking you. It's just the random question I'm asking from you. हाँ जी, बताएं मुझे. Option number A. Asta you says option number A. Selivanov test. Vicky says option number A. Ashish says option number A. Is this thing rightly said by you? Radhesham has said the right answer. Option number D. Barford test is actually the chemical test used to distinguish between monosaccharides and disaccharides. Monosaccharides, for example, if I just talk about glucose, okay, fructose, and if I just talk about disaccharides, okay, combining two monosaccharides, we are going to get disaccharides. Suppose glucose plus fructose giving us sucrose. Fine. And if I talk about this Barford test, if I just talk about the Barford reagent, it is basically CuSO4 and acetic acid. CuSO4 and acetic acid, dear one. Okay. So it is going to actually going to distinguish between monosaccharides and disaccharides. How come? So this reagent, it actually works fastly with monosaccharides. So in monosaccharides, if I just talk about monosaccharides, so over here we are going to get faster formation of what? Formation of red precipitate within 2 to 3 minutes. Okay, wherein if I just talk about disaccharide, so if in disaccharide we are actually putting the Barford reagent, CuSO4 and acetic acid, over here there will be the slower formation of red precipitate, taking about 7 to 8 minutes. Okay, fine. No issues. Okay. ठीक है. Yes, Karthik, you need to revise. Polymers and biomolecules, straight away questions आते हैं and you need to go ahead with this particular thing. Yeah, of course. So over here is the Barford test which is going to distinguish between monosaccharides and disaccharides. क्या आप मुझे बता सकते हैं what is actually the use of Selivanov test? Selivanov test के बारे में अगर मैं जानना चाहूँ, if I just talk about Selivanov test, तो बताइए Selivanov test is used for distinguishing between what of those two things? What's basically the use of Selivanov's test? If we are talking about all these things, we should actually talk about all other options also in order to actually tell you about the things. Hanji, Selivanov test is basically used for distinguishing between ketos and aldose. Okay. So if I just talk about keto, suppose ketos and taking ketohexose, so it's fructose. And keto aldose, if I talk about, it's glucose. So between glucose and fructose, if I want to talk about how I am going to differentiate between them, yes. If I just want to talk about how we are going to differentiate between them, yes. So Selivanov test is basically used for differentiating between ketoses and aldoses. Fine. So over here, if I just talk about monosaccharide, okay, if I just talk about monosaccharide and that too ketos, if I just talk about, first of all, what is the reagent we are talking about in Selivanov's test? Fine. So over here, Reagent of this particular test is consists of resorcinol and concentrated HCl. Resorcinol, resorcinol and concentrated HCl. Concentrated HCl. What's the structure of resorcinol? This is the structure of resorcinol. This is the structure of resorcinol. So what it is going to do is, suppose if I just talk about ketose, that is fructose if I'm just talking about. What's the structure of fructose? It's CH2OH, C double bond O. Then what it will be? It will be OH, H, okay. Then it's H, OH, then it's H, OH, and then it's a CH2OH. So it's our fructose, a ketohexose basically. We are going to get deep cherry red color. We are going to get deep cherry, wait a minute, deep cherry red color, okay, for ketoses. Wherein if I talk about aldoses, in case I'm talking about aldohexose, that is glucose, for that I'm going to get faint pink color, or you can say red color, but not deep cherry red color. So herein there is a difference between ketoses and hexoses. Okay, fine, clear हुआ ये वाली बात? Okay ma'am. Even if I just talk about ketose, in a way disaccharides, I'm talking about sucrose. So sucrose is ketose disaccharide. For that also we are going to get cherry red color, a positive test for Selivanov. Okay, clear Astha, Karthik? Fine. Okay, that's absolutely fine for Selivanovs. Okay, talking about iodine test is basically used to detect the starch from a sample. And how is the detection? Blue black color is what we are going to get if the starch is present in the sample. Okay, fine. Talking about tolerance test, a very famous test to have a difference between what? Aldehydes and ketones. Okay, so white precipitate of silver, if I just talk about, what we are going to get is basically, in tolerance test, it's the ammonical silver nitrate test. We are going to get a silver mirror in case if we are having aldehydes. Yes, of course. Fine. Done. Okay, fine. So for differentiating between monosaccharides and disaccharides, it's the Barford test. Option number D, the right answer. Iodine test is basically used to detect starch from a sample. Okay, suppose if you are having potatoes, so in potatoes you do have starch. So when you put the iodine solution, you are going to get a blue black color. So this is how you are going to differentiate whether a particular sample do have starch or not. ठीक है? Okay, Vivekanand ji? Yes, ma'am. चलिए, so it was option number D the right answer. Option number D बिल्कुल सही था. Now this is a good question. This is a good question in front of you. So let's talk about the same. How many questions? Okay, a few questions more. You can guess 3 more questions. See, the marathon was of 3 hours, but what we did, we actually completed our session before 3 hours. Okay, no issues in that. So which one of the following compounds will liberate carbon dioxide? Which one of the following compounds is going to liberate carbon dioxide when treated with the sodium bicarbonate? Now the sodium bicarbonate is basically a weak base, so it is going to react with acids only. Hint I have given to you. Let me know the right answer of this particular question. इसका right answer क्या होगा वो आप मुझे बताएं. Just let me know. Manisha, Astha, Shruti, Vishwa. Okay, fine. Just let me know. Come on, dear ones. हाँ जी बताएं मुझे. Okay. Option number C you are saying, amide you are talking about. C shayad, not confident about the question. See, the compounds which are more acidic, than NaHCO3 releases carbon dioxide. Well, this NaHCO3 is a weak base. Okay, fine. If I just talk about CH3NH2, okay, and if I just talk about one more thing, CH3 N positive OH negative. This CH3NH2 is basic in nature, isn't it? It is a basic in nature. If I just talk about CH3 N positive OH negative, it's basically it's what it is. It is a basic salt. So they are not going to release carbon dioxide. A and D, they are not going to release carbon dioxide. Okay, it's basic salt. We are left with B and C options now. If I talk about amide, okay, and talk about this hydrogen. So this hydrogen is acidic, but it's actually not as much acidic enough. It's not acidic enough to liberate carbon dioxide. Okay, if I talk about this hydrogen, I'll say this hydrogen is acidic, but it is not as much acidic to liberate carbon dioxide. So this is also out of the race. We are left with it's CH3 whole twice NH 2 positive, and it is Cl negative. Well, if I just talk about this particular compound, okay ma'am, tell us about this particular compound. Okay, so this is acidic salt basically. This is acidic salt. This is acidic salt. How it is actually being made? Okay, how it's been actually made? It's CH3 whole twice NH plus HCl. This is what we are having. Fine, since this is acidic salt, so it's going to liberate carbon dioxide from NaHCO3. Clear? Is the thing clear to you or not? Just let me know about the same. Fine, clear? So यहाँ देखिए it's CH3 whole twice NH2 positive Cl negative we have plus Na positive HCO3 we are having. HCO3 negative we are having. So it's NH H over here and it's chloride over here. HCO3 is going to take this and this is going to be here like this. Fine. So in the end we are going to get CH3 whole twice NH plus NaCl plus H2CO3. H2CO3 is a weak acid which is further going to decompose into H2O plus CO2 like this. So it is option number B, the right answer for the question asked for. Clear? Done, done. Clear? Okay. How we are going to find out that whether a particular hydrogen is acidic or not? After the removal of hydrogen, you are going to get a conjugate base. And if you are getting the conjugate base stable enough, you can just consider that the hydrogen you have removed is the acidic hydrogen. Fine? Clear? Chaliye. Let's move ahead and let's talk about this particular question. Which of the following statements is correct? Which of the following statements is correct? इसके बारे में बताएं आप मुझे. Come on, dear ones. इसके बारे में आप मुझे बताएं. Gluconic acid के बारे में हम बात कर रहे हैं. Gluconic acid is a dicarboxylic acid. Correct statement बताना है. Gluconic acid can form a cyclic acetal or hemiacetal structure. Gluconic acid is a partial oxidation product of glucose. Fine. Vishwa, I see, truly, if I just talk about, I really don't have any idea about this particular thing. Fine. Talking about option number C again, gluconic acid is a partial oxidation product of glucose. Gluconic acid is obtained by the oxidation of glucose with HNO3. So which particular statement is the correct statement? Can you just let me know? Sabse pehle you should know about gluconic acid. What's the formula of gluconic acid? Well, let me tell you one thing, that gluconic acid is actually formed from the partial oxidation of glucose. Okay, so what is glucose? It is CH double bond O over here. Then it's HOH, fine ma'am. Then it's OH, H. Then ma'am, HOH. Then it's HOH. And then it is CH2OH. Then it is CH2OH. So it is glucose. So on partial oxidation we are talking about ना, partial oxidation. Yes. So अगर मैं इसका partial oxidation कराती हूँ, suppose करो it's bromine in the presence of water, or you can say it's the tolerance test we are actually talking about. What we are going to get is it's C double bond OOH. Fine. And just have a look. It's HOH over here. Then OH, H, then again HOH, HOH, and it is CH2OH. This is our gluconic acid. ये है हमारा gluconic acid basically. ठीक है? अब if we are saying that gluconic acid is obtained by the oxidation of glucose with HNO3, okay. So अगर, or you can say if I just make it to react with, glucose with HNO3, what I'm going to get is glucaric acid I'm going to get. So in glucaric acid, it's this, then it's C, wait a minute, glucaric acid I'm going to get. Yes. So it's COOH, then it's HOH, OH, H, OH, HOH, fine, and then it will be COOH. 1, 2, 3, 4, 5, 6. So this is glucaric acid I'm going to get. And this glucaric acid is what? It is dicarboxylic acid. Well, they are saying that gluconic acid is a dicarboxylic acid. No, gluconic acid is monocarboxylic acid. So statement A is the false statement. Gluconic acid can form cyclic acetal or hemiacetal structure. See, it can form cyclic structure, but saying that it is going to form acetal or hemiacetal, cyclic hemiacetal or cyclic acetal structure, it is actually false. Why? Because for cyclic acetal, okay, or cyclic hemiacetal, there should be the requirement of CHO group. In gluconic acid, we are having COOH group. So over here, we are actually going to get what? The cyclic ester you can talk about, but not cyclic acetal or hemiacetal. For that, we require CHO group. For that, we require CHO group. Suppose if I just talk about its cyclic structure, removal of water, H2O, okay, so it's alpha, it's beta, it's gamma and delta. Okay, so this OH group and this OH group, if I just talk about, take them minus H2O. Now if I just talk about the cyclic structure of gluconic acid, okay, so what will be the cyclic structure of gluconic acid? Just have a look. It will be the ester I'm going to talk about. O, C double bond O, then over here it's carbon, fine, so it's H, OH, and this carbon atom is alpha carbon atom. Clear? Fine. This carbon atom, and over here we are having CH2OH. Fine. Then this carbon atom, it's hydrogen, and OH over here. This carbon and this carbon. So it's OH over here and H over here. So it's alpha, beta, gamma, and this one H over here, it's delta. This one is delta. Fine. Clear? Okay, so this is the cyclic structure of gluconic acid. Cyclic structure, which structure? Ester 1. Fine. So over here, this is actually known to be as glucono-delta lactone structure. The cyclic structure of, but it is not cyclic acetal or hemiacetal because it is not having CHO group. Rather, we will say it is a cyclic ester structure of gluconic acid. Hope this is actually clear to you. This is actually clear to you. Fine. Okay, ma'am. So, chaliye, if I just talk about option number B is false, option C is actually true, and option number D is also false. So, in a way, what we are going to talk about, it's option number C the right answer. It's option number C the right answer. Okay. It's option number C the right answer. Okay. Fine. चलिए, और किसी को कुछ कहना है? Okay, fine. Let's move on to the next question, or I believe the last question. Till now, if you have any doubt, just let me know. Just let me know about the same. Okay, don't have any doubt? Okay. Done. चलिए, what I'm actually seeing is एसिटल पार्ट एक बार और क्लियर करूं. किशोर, वहां पर ग्लूकोनिक एसिड में वी वर हैविंग COOH ग्रुप. फाइन. They are actually saying that we do gluconic acid have cyclic acetal or hemiacetal? So for having cyclic acetal or hemiacetal, there should be CHO group present, not acidic group present. If there is acidic group present, then what is going to have? We are going to have cyclic ester structure of what? Gluconic acid. That is what I have drawn it for you guys. Okay. Fine. Clear? चलिए. Okay. Anyone any doubt now? कोई doubt हो तो बता दीजिए. चलिए. Fine. Okay. The last question of the session. How fast we have come to the end of the session, ma'am. Why not? Let's continue. See, today I do have 35 questions. I thought they might be completed in 3 hours, but they are actually completed in less than 3 hours. Okay, it's only 2.5 hours we have given to these particular questions, because we were actually fastly covering each and every questions, and you were actually responding to me in a better way, so we completed it out. Fine. So herein we'll be talking about the same. Now, what should I say? Chaliye. There should be some more questions, but today not. The next Sunday, again, we are going to have the chemistry marathon. Beep there. There will be some more questions that time. And yes, you should be present there. Of course, Asta, that is what we need to actually go ahead with this. Fine, 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 clear, clear. ठीक है, तो चलिए. So, अभी कार्तिक was asking something to me, ना? कार्तिक कुछ पूछ रहे थे आप मुझसे. Yes. So देखिए, एल्डोनिक एसिड जो आप कह रहे हैं, एल्डोनिक एसिड के बारे में, it is actually formed by the oxidation of carbon 1. It is actually formed by the oxidation of carbon 1 in glucose, and that is actually known to be as designated as gluconic acid. ठीक है, तो एल्डोनिक एसिड के बारे में हम कह सकते हैं कि एल्डोनिक एसिड कैसे फॉर्म हुआ, बाय द ऑक्सीडेशन ऑफ कार्बन 1 इन द ग्लूकोज, और उसको हमने कह दिया क्या, ग्लूकोनिक एसिड. तो एल्डोनिक एसिड कैन बी सेड एज अ ग्लूकोनिक एसिड, वो हम एक्चुअल में कह सकते हैं. ठीक है, डन. इसका आंसर क्या है? वेल, सभी को इसका आंसर पता होगा. वैसे आपको एक बात बताऊं, बहुत कंफ्यूजिंग है ये पर्टिकुलर क्वेश्चन. द मोस्ट सूटेबल रिएजेंट पूछा है फॉर द गिवन कन्वर्जन्स. तो मैं आपको एक बात बताऊं, देखो NaBH4 हो, चाहे हाइड्रोजन इन द प्रेजेंस ऑफ पैलेडियम हो, चाहे लिथियम एल्यूमिनियम हाइड्राइड हो, चाहे B2H6 हो, डाइबोरोइन हो, दे आर एक्चुअली गोइंग टू डू वन थिंग, एंड दैट इज वन पर्टिकुलर थिंग. देखिए, ये एज इट इज है, ये एज इट इज है. ओके, दिस इज एज इट इज. ठीक है, बट यहाँ पर वी डू हैव अ चेंज. इट्स COOH ग्रुप चेंजिंग इनटू CH2OH ग्रुप. ठीक है, तो यहाँ पर इट इज एक्चुअली रिड्यूसिंग. हम एसिड को, वी आर एक्चुअली वी टॉक अबाउट एसिड को, वी आर रिड्यूसिंग टू एल्कोहल. एंड द मोस्ट suitable, or I should say highly selective reducing agent for carboxylic acid, highly, write it down, highly selective reducing agent for carboxylic acid, okay, is diborane. So highly selective reducing agent, exclusively, yes, of course, exclusively. So it's B2H6, exclusively used for reducing carboxylic acid into alcohols. Is the thing clear? So we are going to mark option number A, most suitable. Rest, I'll say all are actually going to do the same work, but highly selectively will be done by B2H6 only. Yes, 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 absolutely right. For acid reducing agents, it's basically the reducing agents for converting acids into alcohol. Fine. So that was all from my side for this particular session, dear ones. Hope that you have actually loved the session. You have learnt huge amount of things of organic chemistry from these super 35 important questions, and we'll be bringing such type of series for you again on the coming Sunday. The next Sunday we'll be actually talking about the same. We'll be having the marathon of again 5 hours for you guys, and yeah, we'll be solving more questions. Okay, so till then I'll just say that go ahead with your practice sessions. I mean to say, you need to practice a lot, dear ones. Go ahead with that particular thing. Well, thank you so much all of you for cooperating with me in this particular session. I rest my case here, and we'll be meeting you soon, very soon. So do subscribe the channel for the further updates of these sessions that are going to happen on this particular platform. Bye bye, dear ones. Bye bye.